Good evening, sir.
Morning, Dr. Harish. How are you?
Yeah, fine, sir.
Good evening for you all.
Thank you, sir.
అనుకున్నాను
A warm welcome to Mr. Keshwan K. Mannar. It is our distinct honor to welcome Mr. Keshwan K. Mannar, a distinguished industrialist and accomplished professional. He is currently working as a engineering manager at LinkedIn in the United States with a total of 20 years of experience across various companies. Mr. Keshwan K. Mannar has demonstrated exceptional expertise and leadership in the industry. Throughout his impressive career, he has contributed significantly to renowned organizations, including Cisco, Broadcom, Wipro Technologies. Mr. Keswan K. Manna, remarkable journey in the tech world began with the foundation he built upon earning his BTech degree from the prestigious Anna University in 2006. We are privileged to host such an eminent personality and look forward to gaining a valuable insights from his wealth of knowledge and expertise. Thank you, sir. Over to you, sir.
Wonderful. Is it okay if I share? Uh, can you all hear me well?
Yes, sir. It's audible, sir.
Okay. Okay. I'm hoping you can all see my screen.
Yes, sir. Yes, sir.
Yes, sir.
Okay. Wonderful. All right. Just some housekeeping stuff before we proceed. Okay. Okay. Wonderful. I think everything is set from my side. I hope you can all hear me loud and clear. So, good evening, everyone. Thank you so much for joining today's session. I hope you're all doing well. I'm sure it's already 6 p.m. So, yeah, let's get started. First, I would like to express my sincere gratitude to good friend Mr. Andilip Kumar, Assistant Professor, and the organizing team for giving me this wonderful opportunity to share my thoughts with all of you. Let me I'll just go on to the next slide. Okay. Just a brief introduction. Thanks for the very kind words and wonderful introduction, Dr. Harish. My name is Kesavan, and I'm a software engineering manager responsible for building software that powers the network of LinkedIn's data centers. While my primary focus is on networking, and I've done networking all my career, I find the principles of AI and embedded systems, increasingly relevant to my field. Though I'm not a subject matter expert in robotics or AI, I'm excited to share insights and ideas that I hope will inspire your research and teaching. The, the topic we are going to discuss today is embedded AI in robotics. This is an exciting and rapidly evolving field that bridges AI and real world applications through robotics. Over the next hour or so, we'll explore how embedded AI is reshaping industries like healthcare, agriculture, and education, and, and discuss how you can integrate these concepts into teaching, research, and even student projects. I would like to keep this session interactive, so please feel free to raise your hand or put a question in chat or even shout out if you have some questions or comments about anything. We can pause to discuss that. Um, so to start with, I'm curious and I'm interested to know from the academic field what excites you all most about AI and robotics. Um, if you have some time, please feel free to leave your thoughts in the chat. That would really help to kind of keep the dialogue going. Um, okay, I'm sure you've all been hearing a lot about AI everywhere, and I'm sure in the last few days as well. So let's take a moment to cover some core concepts in AI that are shaping today's conversations and developments across the industry. The first is LLM. I'm sure you've heard this term multiple times. They stand for large language models. These are AI models trained on massive data sets of text, enabling them to generate human like responses. Example, ChatGPT, you must have heard Google Gemini, or transforming how we interact with AI for tasks like summarizations, question answering, coding, and most call centers, the automated call centers, and even sometimes feels like human. They're all run by the AI, which is powered through this LLMs. It's very common LLMs are the OpenAI, you might have heard. Facebook has released something called Llama, and Hugging Face also has a lot of free open source models as well. The second most important concept is core concept is generative AI. This refers to AI that creates new content such as text, images, or music. Machine learning. I'm going to open up the chat as well on the side just so that if somebody pings, I can. Okay. Machine learning, a foundational concept where AI learns from data to make predictions or decisions. And you might have all probably done a lot of courses as well. Statistics, probability, those are the core key mathematical concepts that are required in machine learning. Next is deep learning. Deep learning is a subset of ML. It's a smaller portion inside ML that uses something called neural networks to solve more complex problems. For an example, image recognition in self-driving cars is a result of an NL, deep learning. The next very common core concept is NLP, natural language processing. This is the backbone of conversational AI, enabling systems to understand and respond to human language. Virtual assistants like Alexa or Google Home or any other chat system that you have come across is powered through this concept of NLP. Then a more interesting topic is called ethics and responsible AI. A critical AI area ensuring that AI systems are fair, unbiased, and explainable. Anytime you read about AI, the common term that you will come across is called hallucination and bias. So we got to be, which means that it's AI is not no different than a kid at your home. For every question, they have some answer, may or may not be correct. So it's there is a lot of responsibility and ethics associated to that. The last topic I wanted to bring attention in this concept is Edge AI. This is where the future is. AI that processes data directly on devices like smartphone or IoT system, reducing latency and dependency on the cloud. Facial recognition on your mobile phone or drones navigating autonomously. Those are, these are the concepts not only form the backbone of AI, but also reflect the current state of AI conversations, particularly with advancements like LLMs and generative AI. So I know it all sounds like too many concepts, but the more you read about all of these things, the more you understand that it's no different than how we've learned mathematics, physics, biology, and everything. Keep reading about it, you will get to know. Um, so before we proceed, I have a question for all of you. I'm sure you've all heard the term GPT in ChatGPT. What does GPT stand for? I'll give 10-15 seconds for you all to respond in the chat. Um, I'm curious um, to hear some options and thoughts. Yeah, general pre-trained transformer, generative pre-trained transformer, general predictive transformer, generative predictive transformer. Yasmin, there are no wrong answers. Yeah, feel free to share whatever you think. Anyway, thanks for all the answers. Most of you have gotten it right. So let's go with it. It is generative pre-trained transformer. That's what GPT stands for. And why is it generative pre-trained transformer? Is because it's generative because it generates text, music, images, videos. At the end of the session, if you have time, I can even show you some demo of AI generating a video or image for whatever we ask. It's pre-trained. It's trained on massive amount of data before fine-tuning. So there are the stages called fine-tuning, so pre-training and fine-tuning. People use the term training, but it actually means pre-training. So we pre-train the model. It's like building a knowledge. It's like in the movie Matrix, you see that, hey, now I need to learn Spanish. Then it downloads a package. Suddenly the character now knows Spanish. So it's pre-trained. Transformer is the architecture. That's the whole thing is built on. So this is what makes models like GPT capable of understanding and generating human-like responses across a wide range of topics. So thanks for all your answers, and I'm glad most of you have gotten it right. So, okay, moving on. Okay, so this is our key concept for today, which is embedded AI in robotics. I would like to start by breaking down the key concepts in AI, embedded AI in robotics. Before I proceed, anybody has any, I know somebody has a question on how bio-inspired algorithms used in networking area. It's a little, I can cover this at the end of this whole thing, Rohini, if it's okay, because it's a generic question, and I'm sure there will be more such questions as well. So, okay. First, what is an embedded system before we even go into embedded AI? Embedded system is a specialized computing system designed to perform dedicated tasks, often within a much bigger system. For example, a microcontroller inside a washing machine, or your cars, or every other system that, like, big vehicles. There are lots of sensors in place, and I'm sure you're all doing a lot of project with sensors as well. So any sensors in a much bigger vehicle, that's an example for an embedded system, right? What is AI or artificial intelligence? AI refers to this machines mimicking human intelligence, like learning, reasoning, or decision making. So please remember this. It's AI is not about just I think somebody. All right. So it's not just about treating AI as your personal assistant, but treating AI like your partner, where you can reason it out. You can discuss, debate, and AI will come up with its own rational and reasoning and decision making. Now put two and two together. What is embedded AI? Embedded AI combines these two fields, AI and embedded systems, by integrating directly in the hardware of the robots. This enables robots to process data, make decisions, and act autonomously in real time without relying on external systems like the cloud. Why is this important? Imagine a scenario where robots must respond instantly. For example, now almost everywhere robots are assisting doctors and in the operating theater, right? So to ensure all precision and safety, robots does a lot of operations today with the assistance and help of a human doctor. An agricultural robot monitoring soil and crop health. It's not like before, where you add some manure and you do your regular soil treatment and wait for things to happen. People monitor regularly, and robots monitor regularly, especially in this thing called precision farming. And most people, even in India, are doing a lot of these things today. And then campus, right? Like, college like yours, there are you can, there are all these automated attendants in the classrooms, the AI digital libraries that are there. There's a lot of kiosks which can act autonomously as well. Now, can you think of situation in your college or community where real-time decision making by robots could be helpful, which either is not there today or are being done by humans? AI and computers are good at repeatedly, tirelessly doing repeatable jobs reliably. So if you can think of some situation, that's a good idea. A project. Okay. I'm going to pause 2 seconds to see if there is any question so far in any of these basic concepts. This is very important before we proceed. How can we expect autonomy regarding embedded robot in medical field as a part of safety measure? So again, this is where model training comes into the picture. So some of these systems, imagine the case where we are hearing a lot about self-driving cars. Self-driving cars make decision on whether to go left or right. It's like Google Maps. Imagine it has not just Google Maps today tells you take left or take right, right? But instead of it, it also has the ability to now control your steering and then does take, to say take left or take right. This is a cloud-powered way to make decisions. But imagine your mobile phone can operate sometime in an offline mode, which has enough power in it, computing power in it to take decisions and have the data enough from your surroundings to make the decisions autonomously. OpenAI malfunction, can you explain why? I'm not sure what you mean by malfunction, but you might have to be a little more. If you're referring to hallucination, that's just the nature of OpenAI, like not OpenAI, generally any AI tends to give answers to every question. So sometimes it could be just an imagination, may not necessarily be true. How can we directly integrate in robotics? You're already doing a lot of these things in Sorry, somebody said something. Please go ahead. Okay. We are already in, when I say how can we integrate directly in robotics, you see lots of robotic prosthetic arms, legs, and everything. People use it in Paralympics, you might have seen. So there's a lot of a way we're engaging. Now the question is, can it also think? That's the question. Give me some advanced machine learning which are developed recently. The best place to go for is go to Hugging Face website. They have I'm not I don't follow every, that's not my core field. But Hugging Face has all the latest 700 billion parameters model, trillion model parameter, parameters models, all of those things are there. Llama is a very common open source model released by Meta or Facebook. And then there are many closed models like OpenAI, Gemini, all of those things, which are open. You can access through APIs, but the models are closed. There are other open source models as well. Thanks for your questions. I'm going to move on to the next slide. Okay. So I want to talk about what are the differences between an embedded AI and traditional AI. You're going to get this slide. I'll send this slide anyway to the organizers at the end of it, and you should be able to go through that. I don't want to make it a little boring for you, but The important things are it runs, deployment means where it's going to run. It runs directly on the embedded hardware. You're all familiar with microcontrollers, Arduino, Raspberry Pi. It has to run on a low cost, um, directly on the hardware without relying on external systems. Traditional AI runs on a high power systems like clouds and GPUs and stuff. Data processing, it needs to have the ability to process data and make actions on the data. Whereas traditional AI relies on big data, Hadoop, all external cloud data processing pipelines. Latency has to be very low. So your robot cannot buffer when it's doing an operation, so you don't want that necessarily. Um, but whereas in traditional AI, when you're talking to a customer agent, AI customer agent, it can take 2 minutes to respond back. It's okay. It's not real time. Connectivity, more often, many of the fields and remote areas need robotics or AI to work without connectivity or very little connectivity. Whereas traditional AI requires a lot of constant internet connectivity. Energy efficiency, this is the single most problem that all countries face, is how can they be energy efficient. So please do encourage all, encourage your faculties, your peers, and students to think a lot about energy related ideas. This is the future, right? Um, scalable, which is in very, it has to work in remote areas as well. Whereas traditional AI requires a lot of resources, centralized resources, and can't scale too much. It's already too big. Use cases, robotics and drones for in case of embedded AI. Traditional AI, all ChatGPT, Gemini are all examples of, traditional. Moving on. What are the various applications of embedded AI in robotics? Let's explore how embedded AI is being used in real world. These applications not only demonstrate the potential of robotics, but also provide inspiration for projects in your colleges as well. So, some of the core applications that are coming up as we speak in healthcare, robots assist surgeons with precision and consistency during operations. If you follow the US news with the recent president, Donald Trump, there was a new project called Stargate where they're putting in 500 billion. And in the 3-minute video, they talked about how AI can help identify and even come up with a cancer vaccine. It seems a little ambitious, but any good projects, going to a moon was ambitious when it was announced. So AI can, and Sam Altman, OpenAI CEO, also talks about the velocity or the speed at which we are going to now start curing diseases are going to be huge. So healthcare, it plays a major part in not just embedded AI, but overall AI. If you're interested, go search for Da Vinci. That it's like the Leonardo da Vinci. So Da Vinci surgical robot. It does amazing stuff. Agriculture. Robots monitor soil and crop health, enable precision farming. They analyze the soil, they help irrigation, what crops to put in after when. There's a lot of our forefathers, they used to do a lot of crop shifting or crop, I don't know the exact term, but they don't necessarily plant the same crop every back to back. Manufacturing. Collaborative robots, also called cobots, enhance work alongside humans for repetitive or dangerous tasks. Logistics, autonomous drones, vehicle managed delivery and inventory in challenging terrains. Imagine, uh, having an army of robots and stuff like that. Education, robots automate campus tasks like attendance or library assistance, enhancing operational efficiency. We have robots teaching, we have robots learning, we have robots doing almost everything in campus and enterprises and everything. Which of these applications, so I have a question, which of these applications do you find most exciting or relevant for your college? Yeah, please feel free to chat, use the chat to share this so that it's mostly for yourself. Like, you can, after this, the organizers can go through it and discuss, come up with new forum to talk about AI or embedded AI specifically. Okay, so there is question in chat. I'm just going to take it right now. Choosing right hardware can impact performance of embedded AI. 100% right. Um, Ms. K. Deveshwari, I'm guessing. If so, please suggest how to choose right hardware. Right, that's everybody wants bigger is better, but in case of embedded AI, you first want to be able to identify what is the task that you are trying to achieve, and start building. Start very little, like start if your project is about just automating some systems. Start with a microcontroller. Keep adding as your um, requirement increases. So start small. That's all I would say. Whether it is like, picking up, start with like, if you go to AWS or if you go to GCP, you can get the minimum. There are free instances that might come. Start trying with that, build models with that, and try to deploy it on an, you build that model and put it on an Arduino or, or build a small self-driving car yourself. And, then you can start building it on top of that. Okay. So I want to just briefly touch on what are the key benefits of that, that make these applications possible. The first one is real-time decision making. Yeah, it enables AI systems to respond instantly in dynamic environments like surgeries or disaster zones. Energy efficiency, optimized for low power, perfect for drones or agricultural robots, which are gonna be out in the field for a long time. So it has to be optimized for energy. Cost efficiency, especially in countries like India and everything, if you want it to be reaching all the villages and everything, it has to be um, optimized for cost. For people who remember the beginning of cell phone days, mobile phone used to be expensive, but then I remember one fine day, um, Reliance came up with this 800 rupees or 1000 rupees phone, and now everybody started having phone. It has to be optimized for cost. Customization, robots can be tailored to specific tasks like campus automation, security, and whatnot. Scalability works in remote or disconnected areas. Yeah, you should every single time you have to have ask this. Any single task that you see across your college, you have to put on this innovator hat and think what would help me, or what would help my college, what would help my society, and what would help the people around me. And you start thinking about those generic questions, asking those generic questions, and then you use your engineering principles and the lesson and the things that you have learned to apply and come up with solution. That's how anybody comes up with any new company, is solving real world problems, and I want to encourage that. um, Question on thanks Sushma for the question. Can AI learn a language on its own? In AI there are these terms, like what we are talking about is an AI and embedded AI are just a different forms of AI, right? Whether it is coming in a, you want to go from one place to the other place, whether you're using a bicycle or a car or an auto, that's just different forms of going from one place to the other place. But AI has different levels. What we're talking about is a general AI, but you keep hearing these terms called AGI, artificial general intelligence, where the general idea is like it can think like a human, act like a human, it can make decisions. And then there is this sci-fi level, which is called ASI, which is artificial superintelligence, which is very close to all sci-fi movies, all the way from Terminator to all to the latest, um, you know, movies. And there are movies, interesting movies like called Her, where how a human develops a lot of connections with in AI systems as well. So there's a lot of sci-fi predictions, but that is the general next level of current AI is AGI, and then there is ASI. Very similar to how we have been calling it as supercomputer or hypercomputer. Okay, interest of time, I'm going on to the next slide. So we have talked about AI, we have talked about embedded AI, we have talked about applications of embedded AI, we have talked about the benefits. Now the most important, what are the challenges of embedded AI in robotics? Hardware, first and foremost, hardware constraints. You're going to only have limited processing power and memory in embedded devices. AI optimization, tailoring AI to run on low-cost hardwares like Raspberry Pi. It says real-time performance, ensuring reliable decisions in critical environments. Data privacy. You don't want, like, you have your Alexa or Google Home in your home. You don't want them to be sharing your data that it's collecting from your home outside. Managing sensitive data locally without compromise. And one of the biggest challenge is skill gap. It's especially, bridging the gap in AI, technical expertise gap in AI, robotics, and embedded systems. And this is where I think, um, a lot of you can, being a faculty and being on the research side, come in and do a lot of favor to the community. Is read a lot of papers that are published. May not understand today, but you discuss with your peers and students, and just stimulate the thought, plant the seed of, hey, this this is a topic, and this seems like the applications of this topic seems to be very huge. What do you think? Okay, I'm going to pause briefly to see if you have any questions. Can AI language on its learn a language on its own? Absolutely yes. Is super AI hypothetical or available, sir? So I'm guessing you're referring to the concept of AGI and ASI. AGI, artificial general intelligence. Again, it's if a machine can think itself, to put it very simply, it can be. I think we are very close to that. We'll in the coming months and years we'll know. And the natural evolution is ASI. So all the movie I, Robot and everything, you see that. So all the sci-fi things that we have seen 20, 30 years back are all coming real, at least most of them. So there's no, it could be a hypothetical today, but I don't see, I see a path for it today. At least in the last 3 years since the time AI came in, it doesn't seem like as distant or as, just a movie thing. It looks like it's coming. Okay, I'm gonna move on. I definitely wanted to highlight this aspect, which is, though we have talked about a lot of these things, I believe there are a few projects that you can try. I'm not saying these exact project, but I wanted to see what you all think about it, and maybe there are more more useful and more important things that you can do. But start small, like start with a project that helps your college, your department, right? Discuss with your head of the department, and allocate some budget for it, or scholarship for people who think of idea and present papers, even at faculty level. This field is so new, it does not differentiate too much between a faculty versus a student. It's very new. Every day it's something new coming up. So I'd highly encourage all the way from the people who run the college to the head of departments to encourage and whether it is scholarship or funding projects, so that when I used to do it, I've seen many people go to some third party, somebody who does project for them and pay them. So as long as if even if it's a very small project, if people do it in locally and come up with their own ideas with a group of ideas with collectively with faculties and students, that's the best thing you could hope for. So some projects I thought was like the smart attendance system. We spend like 5-10 minutes every day, every class, taking attendance and whatnot. You could have a small Raspberry Pi with a 100 rupee camera attached to it, and then you can run to do OpenCV computer vision software on it, and then you can start detecting faces and even you know um, marking attendance. So think of that. All you need is a Raspberry Pi webcam and an OpenCV software. Next is a smart notice board. We do all of these things, and IoT enabled device boards have like all small display whiteboards. All you see this in a in even on a small shops, you see them showing like what are the latest prices. Those are all somebody inputs a static information. But think of it, somebody your a HOD does enter some information saying that, hey, we are announcing this new thing in the computer somewhere, and it automatically shows up in a Wi-Fi smart board. So think of um, some things like smart notice board, um, library assistants. I remember back when we used to do when during my college days, people used to do this library book cataloging as a project, final year project. Many people, I didn't do that, but now same thing with AI, right? So a chatbot or a voice assistant. So yeah, most of them you can achieve through a Raspberry Pi or an Arduino, and open source tools are available for almost everything. Um, okay, sir, is there any good cloud platform for data transfer from sensors through Raspberry Pi? I am not sure I understood the question. So if you're asking, you have a Raspberry Pi and you have all the GPIO pins and you connect a sensor, you extract the data from the sensor. You would ideally want to, in the spirit of embedded AI, you would ideally want to process it there. But in case of the smaller projects, like where you want to talk to, you can write an application anywhere. You can write a Python Flask program or a web server which can talk, and even whatever that shows up on your web screen can show up there. So it's like at the end of the day, cloud is nothing but a laptop that is running on the cloud. You can write any programs there. Can we implement machine learning algorithms in real-time motion controlling devices? Absolutely. That's exactly what self-driving cars are today. Or like, if you've seen all the modern day logistics centers, distribution centers, assembly lines, like, you go to Hyundai factory or Ford factory, you'd be amazed. What are the AI model optimization strategies? Um, I actually don't know about that question. Um, I I am not too. My core subject is not. I don't deal with AI day to day. But there are these concepts called fine tuning, and there are these concepts called RAG, retrieval augmented generation. What it means is that if you wanna, so these are standard AI tools, ChatGPT. Those are like your general purpose doctor that you go to. They're not a specialist. But when you have an eye problem, you go to an optometrist or an eye doctor or ENT doctor for nose or throat something. So those kind of specialists are these kind of fine tuning, which is you take the general purpose model and you say, I would like you to be an expert. Now you optimize that robot for legal. For example, you want to learn something about the law, or you want the robot to be an assistant. Now, for example, you give all your college documents to that system, and you say, be an expert in my college related stuff. So when you build an asset, kind of a uh, chat assistant or a voice assistant, and it will be trained on your data. And there is a company called Glean today, Glean, which precisely does that, which is it knows the general knowledge, and then it now goes into your college data, and it'll try to answer everything based on what it learned with that data. And imagine doing that for a, a heart specialist. Though there is a whole wide common sense that you build, but now you're specifically tuning for heart disease. So it'll try to answer specifically for that. So those level of optimization, there are technologies, there are the concepts called fine tuning and RAG, RAG, retrieval augmented generation. Um, is there any standard security to implement in AI? There's a lot. I don't, there's especially bias, especially uh, just the way at Twitter, X, or Meta or Instagram does a lot of content moderation, abuse. All of these things will be done or already being done. Today, if you ask an AI agent like ChatGPT or Google Gemini, they should have enough guardrails in place to not favor politically, for example, or not favor a particular race. Though there are some inherent biases, but they will be built and these guardrails will be actively built. Will embedded AI fully replace cloud-based AI? No. So that's like saying that can a mobile phone fully replace a supercomputer? No. Why most embedded AI devices prefer Raspberry Pi instead of other advanced processors like BeagleBone, Pine 64? I've only experienced with Raspberry Pi, and I've done a lot of projects myself. I built a small, not a self-driving car, but a radio controlled car, um, and put a bunch of sensors on it. And so it's just cost. I don't know the cost of other things, but Raspberry Pi was just cheap. There was a lot of community support there. Okay, I'm gonna go on to the next slide. Question time. Right. Which of the let's see how much it's like your Viva, right? How much people have understood it just for fun. Which of the following environments is most suited for embedded AI in robotics? A, cloud data center. B, high-speed internet connected offices. C, outer space missions. D, gaming consoles. I'll give like 30 seconds for people to respond. I'm curious. Please do respond for this. You'd be surprised. All right. Wonderful. I'm going to repeat the question here. Which of the following environments is most suited for embedded AI in robotics. I've seen a lot of B. I'm gonna or A and B as well. I'm gonna break it to you all saying, sorry, it's the wrong answer. Um, I'd be happy if one of you. So I'll give the answer. Can anybody who's said C, can one of you maybe turn on the camera and give your thoughts on why C? Why you thought it was C? Which is outer space missions.
Actually, as you have told that embedded AI in robotics, that means all the software that should be work independently. We'll be programming that controller such that it can work independently. Where other options are, it's where the internet and all the things we can give continuous input to that. So I thought of outer space missions, which means it can work independently over there.
Okay, okay, that's wonderful. Anybody else?
Sir, but watching lot of movies, I thought of option C, sir.
My wife exactly said the same thing, that she wanted to say C because there's a lot of outer space missions, and there's a lot of talk about Mars and everything. And India is also doing very well in terms of all next Gaganyaan projects and everything. Thanks for all the answers. And Dr. Harish says you're spot on. You're 100% there. You've been a good student, listening very well. So
Thank you, sir.
embedded AI is uniquely suited for environments like outer space because the same thing, it doesn't rely on constant internet. It has to take local decisions. You don't have continuous connectivity to cloud or anything. In space, the robots are equipped with embedded AI almost in everything that they do, all the way from making decisions on, steering, or even uh, adjusting their solars, or even all the way to toilets as well. Can process data locally and make decisions autonomously, right? So, which is critical due to high communication delays with Earth. But now with all this, Starlink project and many of these Wi-Fi coming on, that really cloud, it might change, but it is all an embedded AI there. So thanks, and good. So now I felt this is my second most important slide. The first one is the projects that you must try. This is my second most the things that I would like to insist and request all of you, being the faculties and head of departments and stuff, to have some sort of framework. And I came up with this just for this one called SMART framework. What I would like you all to take away from this is that start small, right? Whatever be it, either it's individually, and before you ask your students to do something, they will get a lot of motivation if they see the teacher doing something, or the faculty doing something, or an assistant professor doing something. So start small. Buy Raspberry Pi, get funding from your HOD, ask your head of department, show them why. This is the startup culture, and this is the innovative culture that everybody is. You should be treat like a salesman that trying to sell an apple, right? My father would, somebody says apple is 100 rupees, my father doesn't know, he'll go and say no, 50 rupees. There is a lot of negotiation happens, but end of the day, you know what you want and you can get the best deal out of it. So start small, keep some budget. And this is a request to heads of departments as well. As I was kind enough to have an HOD for my computer science back in the day, who was like flexible and gave me a lot of options to try different things. So India is coming up to be the next gen thought leadership as well, where a lot of new projects and innovative projects are coming. That starts here. The 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 mindset or the attitude to try, not wait for somebody else to solve the problem. Try and solve the problem yourself. Now I see school students. I saw a Tamil Nadu school student, government school. They've solved some innovative um, stick for elder people or blind people, and some very low cost Arduino sensors for people who can't see. So start small and award a lot of scholarships, and not just for the money's sake, but it just that creates a lot of um, excitement among the students and faculty. Number two, mentor students, and not just students, I would say. If you learn about a particular topic, try sharing that topic, right? And how what it means. It's okay. This field is new. This is not like the age-old physics or something where somebody did it in 1940, 1923, and then they all, if you remember the speed of light experiment, Michelson, he went on a horse 22 miles across to detect it, and we are still teaching the same thing. But this topic is not that. This is the beginning of, like, this is the beginning for everybody. So mentor your fellow people, have an open mind, and mentor. Yeah, advanced research. Try always solving real world problems. You never know. You might come up with an idea that somebody else can form a company, or you yourself can form a company, or your college can, like being a Stanford or a Berkeley or something, can foster new ideas and can generate people that think for themselves and solve real problems and go on to become an entrepreneurs, that India is capable of doing it. So please do advanced research by, again, solving real problems and targeted research as well. Reinforce collaboration. This field has so many different aspects. It's mathematics, it's physics, and every industry expert, like, we are building on legal, biology, legal, law. Every single thing needs to work together. So the only best way to learn something is to share. So please, encourage collaborations and reinforce positive, learnings as well, and transfer knowledge. Last thing is workshop, paper, and these kind of symposiums, or any of these kind of knowledge sharing sessions that you guys that you're all doing. Um, so see which part of this smart framework that you can implement in your respective colleges, and I would encourage you all to think about it and then take something. Like, doesn't have to. We don't have to wait for a new year to do a resolution, right? Um, okay. So what's next in the field of AI and robotics, embedded AI specifically? Now, sorry, actually, this is for in general AI and robot. What's the next? What's the future hold for us? Um, as I mentioned, RAG. Most of the startups today that are being done, any company that says AI, are basically doing either fine tuning or RAG. This is the robots are not accessing knowledge real time, and then they're ready to solve problems dynamically with little to no internet connectivity or what. Not just that, all specialized AI systems that you will come across, and in, like, for example, I've seen musician A.R. Rahman released a music which has the voice of somebody who died few years back, because he was able to train a model based on the past voices, and now it can generate. I'm not going into the question of whether it is right or wrong. That's a different question. Um, but this is the many companies are doing this. Imagine how an accountant manages all in an. There used to be notebooks, now it's all an Excel sheet, but you have no idea what field to go what. But imagine if you've built a system to say, hey, I want to know when I'm going to run out of money, when I'm going to go bankrupt, and it'll go through a bunch of. Then you say, what can I avoid to do that? What part of things I can improve? Where am I losing money? These are all RAG, which is, you're not training anything new, but you're basically retrieving the existing data, and you're doing a lot of you're adding some say, hey, be the assistant. You're giving them a personality, you're giving them a role, and then you're trying to focus their attention only to certain aspects. um, the next is AI agent. Every major company is talking about agent or agentic framework. What you can see, it's no different from how we've built softwares in the past, but this is like, instead of building one single AI system, now you're building a series of, it's like going to a travel agent, except the travel agent is AI, right? And then you go to a dealer company to buy a car or something. There is a salesperson, there is a marketing person, now there is somebody else to write documents, get signatures. So you go across four or five, because everybody has a specialist task. This is individual agent. Instead of building one system to everything, you now build focus agents which can deal with one aspect, and then they hand it off to the other one. So this is also another thing that you will see almost everything. Microsoft released Copilot, where you can build agents. You don't need to know to write code. So this is other field that's there's a lot of excitement around this part. Edge AI. Edge AI means, like, how many of you are familiar with Alexa or Google or even voice assistants on your phone? You want voice assistant to be able to be your personal companion or a assistant or a partner, where it should be able to answer questions when you're driving, when you want to learn, especially this very catered learning. You go on your, when you're driving to college or school or office, you want to learn your way, not like the standard way of, like, all the learnings videos are out there. They're catered for everybody. In mathematical term, they are the uh, you know um, kind of the least common, right? Which is that they take 100 people and they say, for 80 people, this is what I find useful. They generate a YouTube content, or they generate a session for that. But that's not necessary. You don't want to go to a doctor and say, and you don't want the doctor to say, I think this works for 80 people. Why don't you try this? No, you want somebody to treat you for what you have. AI systems are going to get better at that. They're going to specifically, you talk to an AI, start using ChatGPT if you're not doing it, start using Gemini if you're not doing it, something. You get familiar with that. So that's the edge AI. Then the human robot collaboration. You will see a lot of these things where um, almost we are already doing it, we just don't know, but now it will be a lot more prevalent, a lot more affordable, economical as well. Very high level trends. There are a lot more things happening in the world of AI. So I don't think I know enough to cover it all, but read about it, read papers, don't read opinions only. Don't just follow YouTube, your favorite streamer or everything, and just think that that's factual. No, they are generating content. So you will see, not because what it says. So I also want to highlight that read papers released by colleges like yourself. Those are the factual. Look for the data, not just the opinion, right? So anyway, I thought I'll, before, if you have any questions, feel free to chat. Add it to the chat. If not, I thought I'll cover some key questions that could come up for you. How does embedded AI differ from traditional AI in implementation and scalability? Right? We covered this, but I wanted to highlight it. Embedded AI processes data locally, is optimized for low power devices, and is ideal for real time decision making. Traditional AI relies on external cloud systems, making it less suited for latency or real time operations, or even resource constrained operations. Imagine I come from Chennai, so anytime there is a flood, internet goes off, power goes off, you want your systems to work. Then there's an earthquake disaster zone or a remote village, and they have a, you don't have the luxury of putting doctors everywhere, but imagine there is an AI system there which can deal like work like a doctor, but it has to work even without or with little or no internet connectivity. I think India, there's not problem for internet connectivity, but there are still areas where you might not have the same level. What are the biggest challenges in integrating AI directly into the robotics hardware? We've discussed this a few times. So hardware constraint, limited power. I want to emphasize this again. The next biggest thing for every country is the power production and reducing the power consumed by these devices. So whether it is clean energy, green energy, all of those things are the biggest thing. China has made a significant advancement in terms of the amount of power production there. The nuclear, this is calling it a level 5 nuclear reactors or level 3 nuclear reactors, liquid. I think it's called liquid crystal something. I'm not familiar there, but that's the biggest thing. The country which generates a lot of power and in a cleaner, safer way is going to hold the key to the future potentials as well. AI model optimization to fit embedded system, like it said about fine tuning and RAGs. So you have these more common 70 billion parameters, like you would see when you go to this Hugging Face, or it'll talk about AI models which are built out of 70 billion parameters. Some of them are even like trillion parameters, which takes month for it to run and build that model. But now there are that doesn't fit into a smaller thing. There are smaller things like 7 billion parameters, few hundred million parameters, which are actually smaller. So those model, the 70 billion can be optimized with 7 billion parameters. You train again and again. It's called reinforced learning as well. Uh, this is another concept, RLHF, reinforced learning with human feedback. That's something also you'll come across. Balancing real-time performance with cost efficiency. So, okay. Examples where embedded AI significantly enhanced a robotics application. I mentioned earlier, look for Da Vinci surgical robot. It does amazing thing. So, and there are a lot of agricultural drones. We're seeing it. We're seeing the power of drones, especially in all movies, even low budget movies, because it's now very cheap. But think beyond that. Think beyond how it can help, um, like delivery or delivering medicines to remote places when, like, especially things like COVID times and everything. So, what is required for real-time decision making? Low latency hardware, optimized AI models, reliable sensors. Those are at least very minimal thing that you need to build a real-time decision making embedded AI robot. How can we minimize latency? Again, the same thing, but the latency can come from multiple sources. It could be that you could ask a very tough question. Imagine back in the day, downloading a 5 minutes, one song could take more than 5 minutes. I used to operate on 64 kbps dial-up modem back when I was like, growing up. Now you all download like movies real time or play them real time, do gaming online and stuff. So yeah, so reduce like AI models can be tuned and fine tuned to reduce computational load. There are this concept called hardware accelerators. TPU is a Google alternate for GPU called Tensor Processing Unit. Anybody who has worked on ML or even AI, you would have come across this TensorFlow. So those are the key foundational tools that are available in Python already. So the hardware accelerators like TPUs or FPGAs. You're all hardware people. Most of you, at least, you know what FPGAs are. Um, Designing efficient pipelines between sensors and processors for seamless data flow. You would have built some small systems using a breadboard or even with Raspberry Pi GPIO pins, information flows from one end to the other end, and then they process it and then they send it. So it's important to design well. So yeah, these are the reasons how you can minimize latency. Um, okay, so a fun fact: all the images in this presentation, you will not find the same image anywhere else. You know why? Because all of these images are AI generated, and I generated these images specifically for this presentation. And if you ask me to generate the same image again, I can't. Not just AI cannot, because I tell AI that, hey, can you generate an image for my Q&A slide? Um, and it'll generate based on some information, and it made a lot of spelling mistakes. And I said, can you please generate an image with correct spelling? And you see that it even added the correct spelling on the slide. You might have not noticed the first time when I pulled up the slide, but now that I'm saying, it says it has the correct spelling there. And anybody would be like, why is it there? Because I asked, please correct the spelling of your text in the slide. And then it added that correct spelling onto the slide itself. And now if you notice very keenly, the faces are all like not well. Uh, this is all the images. I don't have copyright problem in my slide because all the images here are generated by AI. They are not real. Like they are, if in a sense, they're all imagination, right? So that's something that um, it's so cool about it. Uh, and you can go back to the slide and you see all the slide, all the images that I generated here are all like I've said, like I give me an image for my framework and it generated this image, all the images, all of these images. And I even asked it, like on the left hand side, you would see this classroom. I asked it to generate, can you please generate an image for a smart attendance system in the Indian setting? And it came up with this image. So it's amazing, and I can so that's mostly it from my side. I can I somebody was asking about transparent AI benefits. I actually don't know what it means by transparent AI. I'm not familiar. Apologies there. Apart from C++, any better software for networking? C and C++ are the most common embedded language. Other than um, people would have written assembly language as well, but those are all no longer there. The current language that's mostly used by embedded people are Rust, RUST. So check out that. That's where modern day most people are preferring people writing Rust based language. Um, um, so yeah, so so I can show you a quick demo of like there you go. I really would like an embedded AI now. Can you all hear me? Am I still connected? Or is it just
Yes, we are hearing, sir.
okay, okay. The ChatGPT is done. All right, there you go. We can try this. Generate an image to express my gratitude to this wonderful Indian faculty member audience. Wonderful. Okay. Okay, this is the last thing that I expected. I even wanted to show you I even wanted to show you a video that I tried yesterday. Thought I'll show you uh, an example of it. Yeah, I think one of those models they call diffusion model, and some of these are like non-diffusion models. So you should be able to. Some models don't yet have the capability to generate. So this is the because it's Google, I can't even. Okay. Oh, this can no. I'm so sorry. Maybe next time in my tomorrow's thing, if this is not that I have a presentation tomorrow too. So this is what it is. Now it generated something before. Now I asked it to generate a more futuristic image, right? So it goes and generates it, picks up the kind of same set of people, but just puts it in a very futuristic sci-fi world, right? And so there are this video as well. It's called OpenAI has it called Sora, Sora, which can generate actually up to, at least for what I have, it can generate up to 10 seconds video. And I tried generating a 10-second video for you to show you all yesterday, but unfortunately I don't have it right now. But going to stop sharing there. Uh, that's it from my side. Any questions? Okay. Question from Abdul Qadir. Good evening. I have a question. We know that AI cannot recreate same situations like in the case of images. Then how we are shifting into an era where AI is everything. How well is it prepared for the unexpected things? I don't think it's going to be any different. Go ahead. Okay. So I don't think it is going to be any different than how a human is prepared for an unexpected thing, which is the same situations, give it to two different humans or the same human being at different stages of life. It's game theory. You have absolutely no idea how they're going to do. You can only guess at best, given if you say, hey, a small kid running, seeing you know, sorry, lack of better example. A small kid sees a car going down the street. Kid doesn't know that it does it, like, a small baby doesn't know that it's like the movie Baby Stay Out. It doesn't know that there is danger. It walks into it. Now the same thing with an adult or an old people, they're going to react differently, right? AI systems are at this stage, they're like this, where the chat GPT and all of these things, the natural language processing, in all the text-based model, they're only meant to do one thing: predict the next word, nothing more. Predict the next word. So when you ask a question, it understands the question and it tries by predicting word by word. Okay, what should be the first word? Now that I said this, what should be the second word? This is what it does today. It generates word by word. It predicts the next word, which is very similar to when you start typing your question on when you want to search something on Google. You'll say, what is the favorite? Then it automatically fills in a restaurant. Or you take your WhatsApp, and in WhatsApp, you start typing a first letter and then it auto suggests the next word. You keep pressing the next word, you will realize the pattern that your WhatsApp or your keyboard has learned based on what you often type. Good. I type good, and then it says I click the next first word, it gets generated on my phone in my WhatsApp. So I think it's all. So just type good, and then whatever the first suggestion, you keep clicking the first suggestion, and I'm just clicking it, nothing else. I'm not doing more than that. I'm just clicking the first word that gets popped up. I think I have my filter on. So you see the first word, I keep clicking the first word. That's it, nothing else. And you do this experiment yourself where you will see what kind of, what has AI learned from your pattern, what you usually type. It says that good luck with the HOA, of course. I'm not able the other week, but I'm going for next few weeks or 2 days to go back and forth on my way, some random things. But that's what it has learned based on the pattern that it has seen me typing. Previously, Cisco certificates gave students opportunities to get jobs. What about present scenario? Currently, I am, I've hired a lot of folks, and I tell you that the practical knowledge and ability to write code is very important. Knowing theoretical knowledge is good, but if I can give you a problem and you can come up with a solution for it, that's the most important thing. Your degree, all of those other things are all secondary. This is what reality is today. Now, in the AI world, it's still in early phase. So do a lot of deep learning. I think deeplearning.ai, the same Professor Andrew Ng, who did a lot of machine learning courses, has done a lot of deep learning courses as well. I can see if we can. I do that too. So I'm doing a course on multi-agent system, but I'd highly encourage keep that learning part always going. So Andrew Ng does a lot of coursework here. So there's a lot of courses there. Go explore those courses, and you should find something and keep doing those things. So this is the one way. I would say I lost my chat window. Is learn things and then apply for the right jobs. You'll get it. Is embedded AI will impact for various industries? 100%. Everything that you think it's not even possible. I think few months from now you will think that okay, somebody's actually cracked it. So every single aspect of it, you think wherever humans, AI will not do it, you will see that. Okay, we are right on time. Any further questions, thoughts, comments? Please feel free to share. If not, we can wrap it up.
Dear participants, anybody has any queries? I think no, sir. Hari, sir.
Yeah, sir. Sir, I would like to express my heartfelt thanks to Mr. Keshwan K. Mannar, sir, for providing a comprehensive overview on embedded AI and applications, robotics and AI, smart framework, and future trends in AI and robotics. Your concepts are very helpful for our community, sir, faculty community, and definitely we'll try to implement the smart framework what you have given definitely we'll try to incorporate in our curriculum, and it will be very useful for our students also. Thank you, sir.
Sure, thank you. And thanks for spending some time. I know it's evening for all of you, but really appreciate it. And thanks for the wonderful opportunity to, distinguished community. So, yeah, thanks for your time.
Yeah, thanks. Bye.
Yeah, bye-bye. Take care.
Sir, I'm sharing the feedback in just a few seconds. Dear participants, feedback link has been shared in the chat box. You are requested to submit the feedback at the earliest so that we will start the next session in a minute. Good evening, madam. Lakshmi, madam. I think you are here.
Yeah, good evening, sir. Good evening, professors.
A
Welcome.
warm welcome to Dr. Lakshmi Madam. It is our distinct honor to welcome Dr. Lakshmi D. Madam, an esteemed academic and educator. She is currently serving as a senior associate professor at School of Computing Science and Engineering and Artificial Intelligence at VIT Bhopal, with a total of 27 years of experience across various colleges and universities. Dr. Lakshmi D. have received Publication Star Award for a consecutive years 23 and 24. She also received Kamal Sharma Award and Bharat Academic Excellence Uttama Adhyapaka Award. She has 20 international conferences presented, 90 international journals papers, and 20 book chapters, inclusive of Scopus and SCI. She has 24 patents. She also published 3 books. One of her papers is indexed in the WHO database also. She conducted many online courses, workshops, and FDPs that cover approximately 1 lakh plus faculty have been benefited from this. We are privileged to host such an eminent personality and look forward to gaining valuable insights from her wealth of knowledge and expertise. Thank you, madam. You can take over the session, madam.
Nada. Thank you, Dr. Hari, sir,
you.
for your warm welcome note and introduction. So let me start sharing the screen, then we can continue the session. Yeah, the topic of discussion in the next half is embedded system, deep learning for embedded system. So it is entirely different. Machine learning and introduction to AI, it is entirely different. And whereas deep learning is entirely different. What is the meaning of deep learning? Just to say, for example, the mathematical concept called neural network. Whenever the neural network is used, that is said to be deep learning. Number 1 point. Number 2 point, when we will be using deep learning is when the data is complex in nature. What is complex in nature? Image data is complex, speech data is complex, EEG, ECG signals are complex, and videos are complex. Any data, and even large text, LLM model, large language model, these are all complex data structure. Whenever data is complex, whenever data is non-linear, we may need to use neural network. Let us say, for example, what is linear and non-linear? Linear means direct relationship, linear and non-linear. You can just type here. So this is a very basic question, a very basic question, basic understanding in the data science field. So in this example, if you look at here, these are non-linear function. Even in electronics, you would have studied linear functionality and non-linear behavior. These are linear. It has certain associationship, correlation, or relationship. Those all only will occur in linear relation existence. Non-linear, there will not be sometimes no association at all. There will be some association, but not correlation. It is different. Parabolic or cubic or quadratic. It will be different or elliptic. These are all certain association it may exist. So simple operations we can work out with machine learning like linear association. These all can be solved when the data is simple. When the relationship within the data is simple, then we can go for machine learning. If the data becomes complex, if the data possesses non-linearity in its relationship, what is not relationship? What is data? Data means column, rows. It is kind of, for example, text analysis, large text, natural language processing, the sentiment analysis. These all non-linear. Whenever non-linear plays a role, we need to go for deep learning. That's all about little introduction. The material what I'm using, I will be sharing it with you. Today's material is completely ready, whereas tomorrow's material I may need to heal it further. I may need to cure it further. That you can refer tomorrow. So now I am giving the material. You can refer to it. No need to even rely on the organizing team. Just the material is with you. Preserve the link. This is only one link you may need to maintain. For today's session, hands-on theory, because most of the session when we are attending, we may be understanding a lot of, gaining a lot of knowledge, but where to start, how to start, that problem will be faced by most of the members. So that is going to be resolved today. One such language which is recently supported for the embedded application is Python, TinyML. Python framework, richest framework, that is TensorFlow Lite. After the introduction of TensorFlow Lite, lot of revolution happened with embedded system. So that is the literature says, that is a message conveyed by the literature. Strong evidences are there. So that Python TensorFlow Lite, we are going to look at, and you are going to, get into the exposure towards the hands-on. The single notebook, it possesses hands-on theory, all notebooks. So how you can preserve is this link, you can go for make a copy, or you can download it, or else never I will be locking it. Always it will be kept open. Even for your safety purpose, if you want, you can make a copy, or else it will be available on the cloud platform, Google Drive cloud platform. Anytime, anywhere you can access. Download means it will be on the device, hard disk, Word file. That's it. So now, almost the end of the session only I'm introduced. So by this time, you may be knowing about embedded application. One, the familiar embedded application in our day-to-day life is smartwatch. I am having smartwatch with the 3,000 rupees. Maximum cost of the smartwatch is 2.5 lakhs. Maximum cost Indian rupees. 2.5 lakhs rupees smartwatch is available. What is the extra feature available? Sensors and whatever the gyroscopic sensor and other sensor, accelerometer, all such kind of hardware. Let us keep it aside. Hardware. Software purely based on machine learning and deep learning. That also cost a lot. R&D process to find the appropriate software solution, they will be charging on us. So that's why 2.5 lakhs. The machine learning, deep learning is embedded into the smallest device, that is wristwatch. That wristwatch, how it is doing. That is one classic example. So embedded means smallest miniature hardware need to be resource constrained. What are all the resource? Power supply will be the problem. It will be working on the battery. Directly embedded devices. Sometimes we can even give power also. That is also possible. But power system will be very smaller. Millivolt will be smaller. Supply of voltage will be lesser. That is a number. That is what resource. Then another one, memory. Smallest memory only will be available. Smallest or medium sized maximum. Whenever we are working on microcontroller, then little more better memory space we will have. Then ARM Cortex, that is a popular processor for embedded application. So ARM Cortex has little decent memory, not like computer, not like Arduino, not like Raspberry Pi. It has little decent only. Then what else? The resource constraint, processor. very minimal level of processor. We can even imagine when I was doing my BE in 77 and 94 and 98, born in 77, 94 and 98, the memory size, processor size was very smaller. Maybe that we can imagine. That is the size of the processor. Then another example, for example, at VAD Bhopal, when students are walking, whenever we are riding a car or two-wheeler, never they will be moving. They'll be straight walking. What is the problem is they will be using hearing phone, earbuds. That earbud is not only earbud, it is AI-enabled earbud. It cancels the background noise, only it supplies the music to them. So that how does it cancels? So that a miniature earbud means you all know nowadays that even headphone I about to use, but I denied I don't want headphone. So that earbud is embedded with machine learning application. It is embedded with a deep learning application. So deep learning speech processing, because sound audio analysis. So then not machine learning, deep learning, because complex data. Wristwatch, complex data, deep learning, because data is complex. Sleep pattern analysis, BP analysis, and how much exercise you are doing, all it is taking decision and it will give the health recommendations. So these all resource constraint. Smaller processor, smaller memory, smaller power supply. That's all. These are all three. Wherever exist, those devices are called as embedded devices. That's it. What is the role of machine learning or deep learning? Real-time decision making, automation. This is what. Now, embedded system definition by this time you might be knowing. Leave it. That's why I'm stepping into deep learning. What is deep learning? It is neural network. What is neural network? Just wait for 5 minutes. I will introduce that. Neural network is a name it is kept. Internally, only mathematical operation. What are the mathematical operation? Just filtering, multiplication, addition, division, integration, some kind of small mathematical operations only going to happen. So that mostly deep learning, the operations are matrix based, matrix manipulation. So that neural network, it is said to be a neuronal arrangement, like a brain they started imitating. Every neuron is doing certain computation. Every neuron is contributing in terms of decision making or prediction. So that is deep neural network. What is deep neural network is, it will have lot of layers. Every layer is designated to do certain operation. That is deep neural network. It is used in general, not only deep learning, not only embedded, image processing, signal processing, speech processing, text processing. These are all the four major operations. Already I said audio signal, signal processing, image processing, video also said to be images. That's all. Then natural language processing. These are all the four major area people are applying deep learning. Why these four major area? The signals are complex in nature. The data is complex in nature. Image, RGB, 3 channels. So we may need to do a lot of work. Then medical image. So these are all said to be image processing. Now, what is the challenge with the embedded system? Already every speaker would have addressed this. Even 20 minutes before I have joined, even the previous speaker also telling resource constraint, limited memory, limited storage, limited computational power, limited power supply also. Not only these all. Energy efficiency, immediately it is coming. Battery power devices, mostly battery power devices, very few are chargeable, or you can supply electricity explicitly. Real-time processing, many embedded processing requires low latency. What is the input? Output is immediately required to take decision. That is what low latency. Robot, whenever we are using robot, I am giving some answer, it is replying after 10 minutes. We will feel irritated, right? So immediately response is required. So when we are working with these challenges, how we need to approach deep learning? The moment I say deep learning, highest computational power is required. One example I will tell you. Just 5 years ago, first time I started working with deep learning. Till then, I was not aware of how to work. Theoretically, here and there, I was aware. So 6 years ago, when I started my first project in deep learning, that too internet code, copy paste code on my machine, not this laptop. It is little lesser advancement with this. Yeah, the same laptop. Advanced laptop I'm using at the college. Now I'm using cloud product. It is a different laptop. The same laptop. I started executing the code. Huge noise it started making. Then fan is rotating higher speed. I became frightened. Then immediately all delete control I started switching off because floating point operations per second will be too heavy. So your laptop will be spoiled. Always we need to work deep learning only with the GPU, graphical processing unit, higher computational power, higher. Then we need to work on Colab. Colab is cloud platform. This immediately I'm going to show the hands-on. That is cloud platform. All of the operations are switched over to Google server. It is not going to be done on my laptop. It is safer side. Then you can imagine deep learning, how it is complex, how much operations are happening. So how that complex model, we are going to put it into small model. This is the story. One is like a Rakshasa. Another one is like a small human being. So this Rakshasa need to be put into small human being, small box. Imagine that earbud always. Embedded system means thousands of application, even flight embedded system is available. Whatever the space launching vehicles, it is available. Satellite available. Everywhere the embedded system is available. Even washing machine, refrigerator, everywhere it is available. That all we no need to worry. Simple imagination until the end of the session that a earphone, earbud, wristwatch, more than sufficient. So these two small miniature device we may need to fit in. Such a huge computer processor, model or mathematics, how we can fit into that device. That is what the real research is happening. That is what everywhere the application product development is happening. So for that, what are all the way we are going to do? Model optimization. Optimization is the only mathematical technique available to bring this biggest machine learning model to a miniature device model. For that, only three major deep learning techniques are available. We can take up any one and we can do research also. It is possible. So pruning, being academician, really you may not able to work on embedded system every time. Rather, deep learning, these three research work you can do anytime, suitable for embedded. Pruning. First step is pruning. What is pruning? I will introduce little. During the hands-on time, I will introduce little more. Pruning is all unnecessary weights, or whichever the weight is lesser value, zero value, near zero value, that weight means number, that's all. Weights are number. During neural network, a lot of number will be generated. Just imagine image itself. Suppose this image I am cropping, my own image, what is I'm delivering. That image I am cropping for machine learning, deep learning application. This image is what? 100 cross 100, it may be definitely 100 cross 100 image or 100 cross 150 image, because with this high. So 100 cross 150, what is available? Pixel value. What is pixel value? Number. So within this all number, it has to extract certain features. Based on that, in the near future, my face is appearing. It has to tell it is Dr. Lakshmi. This is how attendance system is working. We are daily putting attendance in the college, right? When we are appearing in front of the machine, it is telling thank you, recognized. My attendance is marked. Today I am present. Nobody is monitoring. So how it is happening? So it starts extracting my features. Sometimes it is failing because here weather is 7 degree, 5 degree, 4 degree it is going. By the time I will put a scarf on, it will not recognize. Then I will be removing scarf for temporarily. So with the specs it is recognizing. Without specs it is recognizing. So it starts extracting certain features. In that feature, whichever the features are extracted with low weightage, that means my background, these all not required. This only required. My hairstyle is also not required. My face, it will be extracting. My dress is also not required. So this face only it is extracting. Then rest of the information is not my interest. Then these all, my background, my fan, this, my wall poster, everything will be irrelevant for the application attendance system. That is also embedded device. Attendance system itself embedded device. Before lockdown corona, we were using thumb impression, all of the institution. That is also embedded device. That is fingerprint recognition. Now what we are using is face recognition. In that, these all irrelevant. My modem is irrelevant. Everything is irrelevant except my face for the attendance system. Then these all of the information will have lesser weightage, lesser number. Then those all not required. Those all need to be removed. The previous speaker was telling some model he was mentioning. I didn't listen because I was booting and I was getting ready with my material because this is a different laptop. So he was telling one of the model Hugging Face something. 7 million parameters are there. That 7 million parameter, how we can put it into embedded device. So all of the irrelevant weights, irrelevant parameters we need to reduce, remove, throw it away. That is called pruning. Carefully we need to throw. Scientifically we need to throw. Just sarcastically we cannot throw. So the important information also will be lost. That is one method. Second method is, this is a direct method. It is not a big deal. This can be set as 0. We can set a threshold. Once we understand the weight, we can understand the threshold. Lesser than the threshold can be thrown away. It is easy. Little logically we need to apply. No research is required. Next is quantization. In this quantization, big number will come after point. Nowadays, most of the computer is having 64-bit registers or 128-bit registers. So it will hold highest precision. So after dot, that much precision I don't want. I can cut down maybe 2 precision, 3-digit precision, 4-digit precision after dot, floating point number. I can retain only minimal. Rest all I can cut down. When I am making the biggest number to be smallest number, then bit consumption will be lesser. 32-bit can be converted into 8-bit. This process is called lowering the presentation precision of weight. Every parameter, what is learned from deep learning, that weight, that what is weight also I will show visually. I have brought animation because maybe most of you are from electronics background. That is why most of the visuals and coding I have brought for your better understanding. So these are all the way model can be reduced and the computation cost of deep neural network can be reduced. Another one is knowledge distillation method. This is little scientific. Those two are easy. With little common sense, little understanding of the background of deep learning, anyone can be done. Until the person understands deep learning very well, only will be difficult. After that, it is nothing. Whereas knowledge distillation is another arena. Teacher-student model. The teacher model is the biggest model that Hugging Face 7 lakh parameter whenever they are using. That if you are trying to fit it into embedded model, we need to create student model of that master model. The master model is teacher model. Technical term itself this only. That miniature model is a student model. That process we need to apply. Then that student model we need to validate. Once if it is working moderately well, that student model will be put it into an embedded device. This is the vast research area. In this, what is a student model? This is smaller, more efficient model that needs to be trained, aims to make the student model perform as well as possible, approximate the performance of the teacher model. That's what I said. Biggest model is a teacher model, giant model. A miniature model is a student model. This imitation we need to create. This overnight we cannot speak. This requires minimum 3 hours to 5 hours session, or anyone need to spend 20 hours to 40 hours in understanding student learning model. Only then you can become expertise. Now, knowledge transfer. Next technique is knowledge transfer. That student teacher model, whatever the predictions or soft label it is doing, whatever the weights or parameters it is learning, that has to be transferred to the student model without deteriorating the generality and with miniature, with little. What is the meaning of, for example, teacher and student? We will be learning a lot. Finally, to students, we will be giving essential information, important information, concise way we will be giving. That is what teacher role, creating a student. Then same method you can think, training process. In the training process, it is called distillation loss and supervisor loss. Sometimes 2 loss will happen. Teacher's model itself, certain loss will happen. that whenever it is transferred and created a student model, certain loss will happen. Those are all the loss it is said. That's all. Then temperature scaling. The another method is temperature scaling. The temperature scaling is the teacher model is to be converted with a smooth transition suitable for a student's model. That is one of the area. This distillation method, 1 minute, something, all feedback session only they are asking. Okay, fine. Okay, this temperature, this is called a temperature, 1 minute, sir. This is called temperature scaling. This one aspect of teacher student model. Within the temperature scaling, how it is doing. Let us say, for example, class 1, this is the weight. Weight means the parameter weight, what we are speaking. Pre-soft max activation layer. So 2 is a value. Nothing to worry what it is. Class 2. Class 1 means one person. Class 2 means I am. Class 3 means another person. Suppose 500 teachers are working, 500 classes are required to recognize everyone's face. So in that weight 2, 1.1, let us imagine. Temperature, if you are setting 2, then how it is calculated? Not 1, it is 2. Temperature, if it is set as 2, now this is a formula, e to the power of z divided by summation of e to the power of z. We need to do every class, we need to apply. So when we apply this formula, e to the power of 2, this is the answer. E to the power of 1, this is the answer. E to the power of 0.1, this is the answer. This is what weight for every person face, let us imagine. Then how we need to proceed is, we need to add these all of the weights. Then we will get the cumulative weight. Then for every weight, we need to divide by normalize. This is called normalization. The cumulative weight will be divided. This class 1, 7.3 divided by the cumulative weight. Class 2, 1.0 divided by cumulative weight. Class 3, 0.1 divided by cumulative weight. These three. Then these all are said to be, it is said to be temperature scaling. This we may need to do for the, this is one aspect of teacher to student model. Like this, several aspects are there in order to convert teacher model to the student model. These are all the way numerical understanding. Now, without temperature scaling, what will happen? With temperature scaling, what will happen? This is for temperature scaling. Without, this is the answer. Originally, we have got. Then with the temperature scaling, these all. Now, what is the meaning? If we look at here, smooth transition, 0.6, 0.2, 0.09. Extreme values are there. 0.6, one extreme, 0.09, one extreme, 0.2 somewhere in the randomly middle. Now, if you look at it is smoothly transitor, smoother distribution, 0.5, 0.3, 0.1. It is little relative to each other. This will be used in the student model. This is one of the aspect, that's it. So now I'm just making little more numerical for understanding teacher student model, that's it. Smoother distribution, and it will easily learn the signal. So these are all the advantage of going for temperature scale. Now the next method is for the deep learning architecture or embedded application, what and all we can use. ResNet. For embedded application within the deep learning, we need to use ResNet. Even CNN we can use. Then we need to go with TensorFlow Lite. We need to bring down with the optimization technique the biggest deep learning model to the miniature deep learning model. That is step by step, let us see. Now MobileNet, QSNet. Directly if you want to apply deep learning technique for the embedded devices, then we may need to use ResNet, we may need to use MobileNet, we may need to use a QSNet. Then these are all the three deep learning architecture or software model. What is the hardware? Edge TPU or ARM Cortex or NVIDIA Jetson we need to purchase. So within these only we can develop certain machine deep learning algorithm that can be deployed, that can be launched for the working model. Now these all of the three models, these three models only, most of the mobile applications people are using. Mobile, anything you want to bring it to the mobile, then ResNet, MobileNet, QSNet. These are all the three recommended transfer learning model or miniature model, we can say. Next is all of these models, foundational architecture is CNN. This is convolution neural network. In today's session, we are going to look at convolution neural network only. So these are all the three architecture. The fundamental way what we need to understand is convolution neural network. Not only for deep learning, not only for embedded devices, any of the application also we can use convolution neural network. But in this session, we are going to apply TensorFlow Lite for the embedded application. 1 minute. No, it is not opening. Okay, let me copy and paste it here. Now, it is a complete guide. I will be keep on increasing the capacity of this material. You can keep watching. Today, whatever is available, with that I will show you. This is what convolution neural network. This is how it looks. This is Zebra. The Zebra is input, convolution layer, ReLU layer, pooling layer, then convolution layer, then flatten layer, fully connected layer, output. Output is in the form of probability value. It is using softmax is one of the function. 0.2 means horse, 0.7 means zebra, 0.1 means dog. Like this, that certain threshold will be there. 0.1 to 0.5, 0.2 dog, 0.2 to 0.3 zebra, 0.3 to 0.4 donkey, 0.4 to 0.5 monkey. This is how it will classify. So this is one intuitive way to understand. This is technical diagram. Now I will make you to understand through wonderful animation related to convolution neural network. So one is TensorFlow Playground, through which it is possible to understand. Another one is through animation, it is possible to understand. Then we can move on to the hands-on practice. See, this is the neural network. Whatever may be your input, you can imagine whatever the input you want. Right now, simple inputs x1, x2, x3. This is the input layer. If it is image, every pixel value is 111 input. After that, immediately we are creating one neuronal layer. That layer, see, plus neuron. What it is doing? This is called weight. You notice weight is minus 0.3. Weight is 4.1. Weight is 0.2. Weight is 0.33. This value which is passed from one level to another level is said to be weight. That's all. These weights are only helping during testing time. If my face every day when I am going to take my attendance, that is called testing process. My training process is over. During the day one of my joining, they will take my photo, 5 different poses they ask me to give. That's all. Using my 5 different messages, that is few shot learning algorithm. So that 5 different phases, they have trained the machine. That time it will start taking these weights. These weights are the guiding torch for the testing. Every day when I am giving attendance, these weights only will be guiding the machine to detect my face and compare the extracted weight of my face today and with the existing face. This is called weight. Now hope so you can understand. Now another layer, I can add layer, every layer. Now here dummy, just we are showing some layers. Every layer has specific functionality. Every layer has specific mathematics. That little bit later. Now last layer. This is a playground. For any new learner is stepping into deep learning, for their imagination, for their understanding, they have brought, see, data. This is completely non-linear. This is much more complex non-linear. You cannot separate it with non-linear. We may need to have boundary with a zigzag. So for this yellow point, the boundary is like this 8. For the blue point, the boundary is like this. Whereas this also little difficult. The boundary is perfect circular, but boundary is non-linear. Whereas this is non-linear. Simplest way it will do. Whereas this complex non-linear. This data to find out the boundary and classify these two, it is complex. So these are all the different layers. We can reduce, we can increase. I am playing. Iteration, epoch. Epoch means the computation happens from input to output. One time is one epoch. Then another time, the computation happens from input to the output. Always back propagation will happen. It is kind of feedback slowly. For example, I started driving a car and I need to get a feedback. People will tell, no, you are not good in this. Then I will be correcting myself. Again, I will start my car. Again, I will apply my skill. I will move forward. Then again, I will ask feedback. They will tell, this is not correct. This some mistake is here. Then again, I will start my car. I will do same method. It will happen until what to say. We stop the model, or only the way the model will be ending, only we stop the model. Human intervenes and stops. How we need to stop? When we are satisfied with the accuracy, no overfitting, no underfitting. Then when the loss is decreasing and again loss is increasing, that point overfitting happens, then we may need to stop. There are again a lot of intricacies that let us not to do, but we only need to stop. Say I'm starting epoch. See now, this it is showing loss, training loss, the boundary. You can notice it is fixing the boundary. It is trying to separate loss, decreasing, again increases, again decreasing, but it is decreasing, increasing, but it is decreasing, loss, stop. 238, see, it is weights are changing. It is becoming more thicker weight and it is increasing, feed forward, feed backward. It is what happening in the deep learning network. For every neuron or for every layer, we may need to design the mathematics. Research means newly we need to create innovation between the layer or within the layer. That is what research. Or else ready-made. We can take the available existing deep learning and we can apply as such. We can do product development. Product development, nobody bothers innovation. They need certain tasks to be completed with the expected result. If that is done, that's it. They don't bother whether we invented new model or existing model. They task to work well with that product. What is the research? Then we need to bring certain novelty in it. That's it. So here again, learning rate. Epoch, you understood? Learning rate. Learning rate should be neither too high nor too low. It should be appropriate. Fixing the learning rate in our model training itself is an art. This is one of the hyperparameter. Hyperparameter is changeable, that is the meaning. Then activation layer, this is highly important. Without this activation layer, deep learning model will become linear. Because of these activation layers only, deep learning models are becoming non-linear, number one. Number two, these are all some of the functionalities will be helpful for labeling the input with the output. So we may have thousands of horse image, but output is only horse. It has to tell horse, that's all. So the thousands of images, how we are going to fit into horse. So that is the another. For that, we need to use mathematical functions. It's all simple function. Nothing Greek and Latin. Simple mathematics, 10th plus 2 level mathematics more than sufficient. These are all the activation functions plays a pivotal role in the intermittent layer and in the output, just before the output layer, several junction, these are all the activation functions are used. We may need to apply our research skill or understanding skill, whatever the problem we are solving, which activation function we need to use at what position or what circumstance. There is no thumb rule available. Whenever we are going for traffic signal analysis, traffic camera installed, whenever you are violating traffic rule, it is capturing your nameplate, your car number. Then that is reported to the RTO office for the penalizing. So how it is happening? It is embedded system. With deep learning only it is possible. But it is a little big camera, right? It looks like big camera, but camera is smaller with a high configuration, but it will have the processor in it. But that is little more higher end processor, not microcontroller. It will not work at all. But a little higher end processor, that is also embedded system. What is the logic working in it is deep learning. Then regularization. These all will be useful for avoiding overfitting. That regularization, we may need to spend minimum one day to understand, teach, or learn. Then regularization rate of applying regularization, classification or regression. In the embedded device, most of the time we may use classification, very lesser time only we will be using regression. That's it. So 80% of the time we will use classification. What is classification? Classify cancer or not a cancer, diabetes not a diabetes, spam or not a spam. That is classification. 2 class I am telling, 10 class also available, 15 class. What is the work we are taking up depending upon that number of classes. Regression, number prediction. See the weather prediction. It is showing 23 degrees Celsius. This 23 degrees Celsius is regression model, numerical prediction. Whenever we are predicting numerical, it is said to be regression. Whenever we are categorizing, that is said to be classification. These are all the fundamentals we need to grasp before stepping into practical. Now, this is wonderful animation. If you look at here, they are giving input. These are all the input. Any input you can take. This is a cup. This cup you can take, ball you can take, dog you can take, any one we can take. So this ball when we take, it's a color image. So this color image, we may need to separate 3 channel, RGB channel, red channel, green channel, blue channel. Every channel, this deep learning model, how it is, see, this is weight. So now this 1 minute. Here weight will not be displayed. Yeah, it is showing, that's all. It is showing, see, it is, it started executing, see, convolution, how it is happening. Every model, what is happening, it will show. So it is one of the fantastic platform I have seen for understanding the deep learning model. See, this neuron, when I click this neuron, what is happening in it? It will show, magnify, input, simple multiplication, max pooling, it will take 2 cross 2, and what is the maximum? It will be reducing. Say one big image, finally it will be brought into 0.1 to 0.8, that range. It will be telling it as horse. So big image need to be brought to one single scalar value. That is what convolution neural network is doing in the image application. Speech application, it will be different. Say again, if you do ReLU activation, how it is doing, 0, 5 point. So it is keep on demonstrating every stage of this convolution neural network for the given set of images, and it will be giving, say, kernel weight and biases. And what is kernel weight is, by this time image processing electronics faculties may be studied also. Lot of kernels are designed. Sobel filter we used to call. That is what here they are calling it as kernel. So it is a 3 cross 3 window, 5 cross 5 window. It can be anything depending upon the filter. Scientifically, people invented using mathematical operations. They have invented a lot of filters. So that any one of the filter, by default it is set. Otherwise, we need to specify the filter in the beginning itself. That filter, it will overlap with the image. So it is showing that, see, if I click this, then it is showing convolution neural network. Here, let us see. Yeah, see, one here, one image, it will be working, overlapping, and it is finding out. That is what convolution layer. What it was showing, no? Why it is not showing? Earlier it was showing. Yeah, it is there. 1 minute. It is there. See that convolution. One black window is moving. See, wherever I am putting cursor, no, that black window is following my cursor. So one small black window is following. That is what to say, kernel. So it will have multiplication. That the kernel value and that pixel value will be multiplying and adding, multiplying and adding. This is what it is doing. Finally, it will give some output. For every area, it does. This kernel will overlap. So how to overlap? That is said to be stride. So whether adjacently we need to have, and we can skip one column, that is stride number 1, stride number 2, stride number 3, etc. It will happen. So this is what the basic understanding of convolution neural network. We can even every stage. This is the best article to learn deep learning. See that kernel animation. The kernel is going, and what is that kernel value and that image value? It is multiplied, and output. What output? Essential features of that image will be extracted and represented. Non-essential features are lost in it. So that cup alone, it is coming. It is like a negative image. The original cup is converted into a kind of red channel. Because of that only it is looking red. So it is becoming. So kernel position. Over the kernel position, it will be doing every step. Then next what it is padding. See, what is the padding? This is kernel. This kernel, I am moving. This is stride 1. Suppose here it is there. Directly if I am moving, stride 2. Suppose it is there. Directly I am moving here, stride 3. I want to skip 3 position. Third position only I need to start. This is called stride. This is what stride. Then kernel size. Now 2 cross 2. I'm increasing kernel size 3 cross 3. See, kernel. Red color is kernel. That pink color. This is 2. This is kernel size is 2. Kernel size 5. That image itself became kernel. Now 4. Kernel size is 4. Image size is 5 cross 5. So it will apply. Then it will reduce that image to say 2 cross 2. 5 cross 5 image is brought down to 2 cross 2. Like this, every time it will step down. Finally, a probable value will be calculated. That probability value only helping to take decision whether the given image is Lakshmi or not, or anyone, every employee, face recognition. Here, dog, ball, cup, it is taking decision. So what is padding? Padding means, for example, this kernel I am moving. When I am moving here, this is 4 cross 4, 4 available. When I am moving here, 4. When I am moving down, it is not possible. Then we may need to patch with 0, 0, 0 with this matrix. It may be 6 cross 6 also. Everywhere we may need to do. See, padding 0. Now I am padding. See, that gray color border is padding. 7 cross 7 padding. Now padding 2. 9 cross 9 padding. So we are increasing artificially, introducing 0. Why? Because this entire image we may need to learn appropriately, not to skip any portion of the image. That's why. Now padding 3. So gray became more, the original image is smaller. So that is padding. Input size. Now padding 6 cross 6. Input size 7 cross 7. So these are all the hyperparameter, everything we need to adjust when we are designing the deep learning model, not only with Python. So whatever concept I'm teaching, this is applicable for whether you use C, C++, Rust or Python. These all the intricacies, how you are implementing these all, how you are going to adjust, how you are going to set, how you are calculating, that only the language speaks. First, we may need to learn the fundamentals theory, then the mathematics, that we need to be sufficient enough, good enough. Then we can think about which language we need to apply. Then that time we can take decision. Language is not a matter. Once if it all designed, every language can be generated by GPTs. The code, what exactly we want, we need to teach to the ChatGPT or any GPT. It will give you wonderful Rust code, C code, C++ code and Python code. I will show you. But what we want, we need to specify perfectly in the prompt. When we want to specify perfectly in the prompt, we need to know the background. When we know the background, I want so and so, so and so, so. This is what my input, this is what my expected output. Generate the Python code. And 100% appropriate code it is giving. Any language, let it be. It doesn't matter. C, C++, Rust or Python. Python means here circuit Python, micro Python, TensorFlow Lite. 3 types of Pythons you can utilize. I'm going to explain today only TensorFlow Lite. So Python version itself, lot of versions they have brought in for the embedded applications. It is highly rich enough. Maybe the computational aspects we may need to compare with the Rust, C, C++. Then depending upon the context and application, we are forced to stick to the type of language. C is a language highly compatible with hardware applications. When deep learning, nothing to do with hardware. Deep learning application means we are giving solution to the external problem. When I am buying a wristwatch, it is monitoring my heart, monitoring my pulse rate, monitoring my oxygen rate, monitoring my activities. So based on that, it is giving alerts, or it is giving recommendation, or it may be communicating with my caretaker. So these are all the roles of smartwatch. Nothing to do with the hardware. What language you are going to use, nobody bothers. When we are doing something with hardware only, we need to be careful about the language. Similarly, noise cancellation, that earbud with that highest AI enabled earbud cost, you put in internet, it may cost around 25,000 also. Small earbud, one time if it falls totally, it will be broken. So, but we can purchase it with 50,000 also. So that deep learning model deeply involved in it, because complete ambience noise, it is arresting, it is completely cancelling. So such a powerful algorithm we need to develop. Then compatibility, then the R&D work need to be fit in, product ergonomics, then fabrication material, internal hardware, all matters in the cost of the earbud. Earbud, we can buy it for 500 also, we can buy it for 25,000 also. One small earbud for speaking and hearing music or listening to the online class, up to 25,000, maybe 1 lakh also available, I don't know. So these are all we need to learn about language little later. How it is working, how the deep learning model is going to work, that is a primary input. For that, we need to learn. We need to do a lot of preliminary activities. Directly, we cannot install the model onto the embedded device. First, we need to experiment, develop, design, validate, iterate, and verify. All the testing we need to do with a normal PC, normal laptop, normal machine, or GPU, whatever, TPU, whatever you are using, doesn't matter. So after it is performed and assuring that it is working well, only we can transfer to the deep embedded application, we may deploy. Until then, we don't have rights to deploy. Otherwise, you may spoil that hardware. So that we may need to be careful. So understanding of deep learning for the embedded application is entirely different. It will be more or less the normal way of learning. That once if it is ready. See, ReLU function, what is doing ReLU function is simple. What is the input coming to this function? If it is less than 0 or less than 0, it will apply as 0. Above 0, it will just pass. What is the meaning is, always if the value is high, it will be passing. If the value is low, it will be diminishing to 0. That's all. 0.0001, 0.0002. Why to waste memory? So that 0.0002 will be converted to 0. It will maintain non-linearity in it. So for bringing non-linearity, most of the time, this ReLU function people are using. This is one of the activation function. This softmax, always it will give the sum output as 1. Suppose I want to identify 10 different faces or 300 faculties. Every institution casually 300 faculties, 500 faculties are working, right? This softmax, finally it will have 1. Every faculty, it will fix the range. If we add these all, it will become 1. It is a classification, recognition system only. When I am appearing for the attendance, it is recognizing or classifying that it is Lakshmi. It is telling Lakshmi also. That name it will display. Only then I will feel, yes, my attendance is marked. So that sum become 1. It will be dividing every image with a certain proportion, smallest range to highest range. Within that range, always it is generated the probable value. It will say that I am. Within this range, it is generates a probability value. It says that you are. For every personality, it will have certain range of probable value. 0.0021 to 0.003, maybe me, myself. So that all of the values are added, it will end up with 1. Suppose 1,000 faculties, 1,000 class, it is said to be 1,000 class classification, 1,000 label classification. To person, it is 2 class label. 3 category, then 3 class label. So this CNN output sum equal to 1. The next one is pooling layer. We may need to slowly bring down to smallest picture. That the pooling, what it will do, pooling layer, there is no animation they have given. So it will be converting one small size 2 cross 2 or 3 cross 3 or 4 cross 4. Within that region, which is the maximum value, it will be generated. That pooling itself, max pooling, average pooling, there are several pooling techniques available. Max pooling means for every small window, the same window we can consider. See, this every small window. Within that, what is the maximum value available, that will be generated as the output. Then the biggest image, how it will be reduced down. Just imagine. Suppose my window size is 4 cross 4, even 2 cross 2. 1/2 of the time, half of the time, the original image will be reduced in the max pooling, 2 cross 2 max pooling. Then if it is 3 cross 3, further it will be reduced. 4 cross 4, still more it will be reduced. This is what max pooling it is doing. Then finally flatten layer. It will be in the form of matrix. That matrix is to be made to become linear, one-dimensional vector. Matrix can be n-dimensional also. N-dimensional matrix, that means R1 matrix, RGB, G1 matrix, and B1 matrix. Maximum 3 dimensions only people are using. Video, multiple dimensions may be available. Only for images, only 3 dimension. So these 3-dimensional matrix need to be brought into single 1-dimensional vector. That is called flattening layer. That is a lost layer. Then after flattening layer, fully connected layer. After fully connected layer, output layer. So these are all the layers we may need to understand or we may need to work. 1 minute. It is not accepting. Yeah, these are all the layers. So now max pool layer. What is max pool layer is, it will be taking, so it is showing this, whatever the window we are taking, it is 2 cross 2. After that, it considers the maximum value of, just see in this scenario, 0.12, 0.04, 0.08, 0.1. So among that all, 0.12 is the maximum. That is shown as the output. That is called max pooling layer. That's all. So this pooling layer will be helpful. Then convolution layer. Every time, most of the time, we may need to work with convolution layer because it has to extract the feature from the original image. Extracting feature is carried out only by convolution layer. Reducing the size is done by pooling layer. ReLU layer is for maintaining the non-linearity. Softmax is used for classification, final decision making. So these all fundamental we may need to understand. With that, we may need to organize these layers. Why these all used? No answer. We need to configure. This is called designing. We need to design the deep learning model. Then we need to verify the accuracy and we need to change the configuration. Something we need to do. That's all about deep learning, visual way of understanding. Now we are stepping into back to embedded system. Now, what are the software tool we can use? TensorFlow Lite, PyTorch Mobile, Open Neural Network Exchange is used for deploying interoperability between 2 different embedded devices, 2 different communicating devices. Whenever we want to use, then interoperability, we need to use ONNX and Edge Impulse. This every embedded specialist need to learn Edge Impulse. Only for deploying machine learning on edge devices. That camera is edge device. Whereas this is embedded device, that headphone is embedded device, wristwatch is embedded device, that traffic camera is edge device. Arduino IDE, we need to use it for deployment. So these all at the end stage. My model is ready, verified, validated. I want to deploy it. Then we need to use this software. There are several applications you would have come across. So now see, this headphone, active noise cancellation, noise isolation, filter background noise. The cost of that device headphone, not 25,000, 15,000 to 50,000 available with deep learning model. Deep learning enabled means this is the cost. So beamforming microphones. Then what are the future trends? Federated learning is going to become. Federated means data is not given to the machine learning because they may steal my privacy. So that machine learning model is sent to the device and whatever the data available. For example, every one of our mobile, every time it is doing machine learning or deep learning applications, but our data are sent to that algorithm, our privacy is lost. So that all of the mobile companies are sending their algorithm to the machine to work on and learn. That learned parameter they will be updating. That is federated learning. Data will not be sent through the computational side. Computational algorithm should come to my device. That is federated. That's all. Edge AI. Mostly we may need to work on edge devices in the near future. New edge device why we are using is cloud. Whenever the algorithm is executed on the cloud, latency delay. Where the cloud is there, Australia, Africa, America, it will be there. My data going there and executing and coming back with the result, it will take huge time. So that is latency delay. Number two, cost. Cloud is always costlier. Initially, it may seems to be cheaper. When you keep using your data is growing, then it will be costlier. So that people are moving from cloud computation to edge AI and neuromorphic computing. How the neural structures are formed, accordingly, the computing device also will take the skeleton. So that is hardware. That hardware is designed suitably for the neural computing, whatever we discuss that neural network for that computation. So these are all the future trend of the embedded system. What are all the key architectures? CPU, GPU, TPU, and embedded system. We are talking about embedded system. For developing embedded system deep learning model, we need to work on these only. Once if we validate, verify, and do miniature model, then only we can transfer to the embedded system. Until then, we need. Then neuromorphic is a highly suitable for embedded system. Neuromorphic. That is the latest research work happening. Not even the field is saturated. Neuromorphic computing is the up to date and it is useful for low latency real-time decision making. So within the embedded, highly challenging. Deep learning with the embedded device for the real-time application is highest challenge. So for the real-time application, they have brought the hardware technique called neuromorphic computing. So that helps for real-time, low latency or no latency. No delay will happen. Input and output, no delay. Quick decision making, energy efficient. So that sort of computational device is neuromorphic computing. Then ResNet explanation is there. Then MobileNet explanation is there. SkewsNet, because we have another 30 minutes to 40 minutes. We need to see the code. Now TinyML, that is theory. Theoretically talking is TinyML. Smallest machine learning model. That field is said to be TinyML. If you want to search any of the paper on TinyML, machine learning model or deep learning model suitable for embedded system, you may need to search with the keyword TinyML. So that is not a language, it is a field of talking about suitable machine learning, deep learning application for the embedded can be termed as TinyML. That's all. So next, low resource requirement, energy efficiency, real-time processing. These are redundant on-device processing. These all we have seen scalability. Now these are applications. Now coming to TinyML, how we can work. TensorFlow Lite for microcontroller. This is authentic information. TensorFlow Lite is a framework. It is a language. It's a Python language using such packages. It is said to be TensorFlow Lite. So this we can use it for lightweight applications. Lightweight version of TensorFlow optimized. This is also light, application also light, microcontroller. We can use TensorFlow. Or we need to use Edge Impulse. One one wonderful YouTube I have come across, Edge Impulse. They are giving end-to-end demonstration for Edge Impulse. You can search on internet also, YouTube also. It is available. One foreign YouTuber. Excellent way they are explaining step by step. That is, but accent will be little different. That's all. Not a purely Indian accent. Then Edge Impulse. We can learn. Developing also it will be helpful. Deploying also it will be helpful. U-Tensor. This is another. This is suitable only for ARM Cortex M devices. ARM Cortex has a lot of variation. What to say? I am using Intel i4 HP. This Intel Core i5, like this 8th edition. No, it is like that. Lot of editions they are having. So U-Tensor we need to learn when you are purchasing hardware from ARM Cortex. When you are purchasing any of the microcontroller, you need to use TensorFlow. No fixed language, my dear friends. Always what hardware you are using, for that hardware, you need to find out the suitable language. There is no universal common language suitable for all of the hardware. This is a appropriate answer for which language I need to use it for embedded learning applications or deep learning applications or machine learning application or AI in microcontroller or AI in embedded devices. What we are using? Processor. Processor when we are using it will be different. Microcontroller when we are using different. ARM Cortex when we are using different. So that is a ultimate answer for that question. Now PyTorch. PyTorch is useful for PyTorch mobile for all of the mobile related applications, small devices are resource constrained devices. Whenever CPU or memory is lesser, this is also Pythonic, PyTorch mobile. So these are all the way then we can use. Then micro TVM. This is another version of software, TinyML compiler we need to use. So all of this framework, what are all the way they are using? Model optimization technique, limited hardware, programming complexity. So toughest program we cannot apply everywhere, and easiest program we cannot apply everywhere, or language. So justification answer, Python is good for embedded system in several ways. Embedded platform supports, most of the platform supports. Depending upon the platform, we can switch over to MicroPython, CircuitPython, or PyTorch mobile, or we can TensorFlow Lite. All are Python centric, but little different, because the package which we bring, the whatever the library which we are bringing, that will vary. That's it. Then portability. Easily you can migrate from one hardware configuration to another hardware architecture. That is the richest standard libraries available. Memory managed. But this is the highest advantage of Python using. When we are using C++, whenever the unused variables, unused matter is there, that no auto cleaning will happen. We the human need to develop different algorithm for memory sweeping. Or else, when we are rebooting the machine only, all of the used memory spots will be cleared. Whereas when we use Python, automatically it cleans it for you. Whichever the variable is inactive, whichever the memory space is not utilized for a long time, it will be cleared by automatically. That is called memory management. MicroPython, I am not having any idea. But CircuitPython, where you need to download, where you need to start, how to start, A to Z guidelines available with Adafruit. This is the only authentic official website to learn CircuitPython. Download also. Now using CircuitPython, one small project we can see. After that, we can go to convolution neural network with the TensorFlow Lite, how we can bring down the model, complex model suitable for the embedded device. Now Adafruit. We may need to download CircuitPython. That is first ready. Any sensor, humidity temperature sensor, low end sensor, high end sensor, DHT 11 popular, DHT 12 popular, 22. So 22 highest temperature 0 to 80 degree temperature, whereas DHT 11 it will sense only between 0 to 50 degree temperature. So some ranges are there. Something is different. It is advanced. DHT 22 is advanced. This is lesser advanced. That's all. So breadboard, jumper wire, USB cable for programming and power. We may need to supply power. We may need to make the code to deploy through USB cable. Then we may need to supply 3.3 volt to 5 volt. Whenever 3.3, 5 volt we are talking, that all miniature devices. That's all. So low power. This low power cannot work with deep learning at all. It will die. RIP to the machine. RIP to the hardware. So we may need to design the software suitable for that. That is the point we are discussing. Ground pin and data pin. Digital input and output. We may need to find out in that microcontroller. We need to fix. Then we may need to install the Circuit Python. Installing Circuit Python, we need to visit Adafruit. Then we need to download latest Circuit Python firmware. That means firmware means it is a software designed suitable for handling the hardware. That is firmware. .uf2, we need to locate that file. That file we may need to bring, copy, paste or install into microcontroller. Then we may need to install necessary libraries. Adafruit Circuit Python bundle. Only then Circuit Python code we can do. Copy the file .mpy and Adafruit bus device folder. These all step-by-step guideline. These all the libraries we may need to bring it to the device. That's all. Then once if it is done, we need to start writing the code. The code will be very simple. Import time related, because humidity sensor and temperature sensor, we will be working or will be taking decision based on time. See, initially when I have shown 23 degrees Celsius, now it is 20 degrees Celsius. 3 degrees Celsius has been reduced. It have been reduced. So it is time based. After 2 hours, if you see, it will be 18 degrees Celsius. Midnight, if you see, 10 degrees Celsius. So it will be keep on varying with respect to time. So we are in need of handling time, so that we need to bring the package called import time. Then import board, so that hardware configuration board communication it is required. Import Adafruit DHT. So DHT related sensor operations, we need this package. So 3 necessary packages we have brought. Then what we are doing, we need to set the software need to communicate with the hardware, that is called DHT sensor. For that, board.d2, that is a pin, data pin. In that pin, Adafruit DHT.DHT11, we need to give. This is called method, Adafruit DHT.DHT11 board.d2. This set when we do, that DHT device will be ready. Now it will be start reading the temperature, say device temperature, device humidity, DHT underscore device. It is not device, it is an object. That object is ready to read the temperature, ready to read the humidity. We are storing it in the temperature and humidity variable. Then that we are printing, displaying. Now how it is displaying, because of that only I am able to see 20 degrees Celsius. So it need to display. It is a simple print command, not the printf. C, C++ and entirely different. C out and printf. Whereas here, print. That's it. This is exception. What is the exception is, sometimes sensor may respond with a delay. Sensor may not respond, some failure. In such a case, it is exception. That time, just ignore. Then print what is the error. Let us diagnose. That's all. Not to stop the program. Just to print what is happening. We need to understand, right? Abruptly the machine is stopping, we cannot understand. So what is the error? That error, it has to display error.args0. Then time.sleep, we are giving some rest for 5 seconds. Then again it continues. Every 5 seconds once we want to do. Suppose if I am changing it into 15 seconds, it will work for me. Every 15 seconds one, it will give me the temperature detail. That's all. Save code.py and run. You want to see the output input with the normal way of interacting with the computer. You can use Mu editor or you can use PuTTY. So this PuTTY is for Linux. Mu editor, you can install any of the operating system, you can utilize. That's all. So this is the way we can monitor, we can observe the temperature and the humidity. So we may need to spend, of course, little expenditure. It could be the laboratory expenditure. One microcontroller and DH11 is enough for Indian temperature. We are not less than 0. We are not above 50 degrees Celsius. One sensor, it will cost very minimal. Then slowly we can acquainted with this coding with the normal PC. Once if it is working, if it is behaving properly, that can be installed back to this microcontroller. Then this one experiment is working well. We can feel confident in what to say. This kind of Mu editor can be installed in Windows. Yes, sir, it is possible. Sujata ma'am, it is possible. Otherwise, you just go to Adafruit. You can read the instruction. So Adafruit. So Adafruit, you can go for reading industries. Here Arduino, Raspberry Pi, new products. So unique Adafruit kit. Then Mu editor, you can verify. Before installing, you can verify. No, this is not. I have given Adafruit link. This is the perfect link. Yeah, the Circuit Python Adafruit. This is the perfect link. So now, if you go here, Mu, it is there. Adafruit recommends using Mu. It is designed for Circuit Python. It is not a matter with the built-in serial console. That's all. It is not a matter where you are installing Windows, or it is not a matter. Just you can try installing. Then on the machine, then it may work it out. So this is one way to work. They have not mentioned anything. You can try it also or read. They have given a lot of code, sample code as well for every program. That's it. So this is the link already. It is mentioned here. You can read to that website so that you will come to know much more clear. Yeah, thank you, madam. All right. So now we are slowly stepping into now the references. What are all the way I have prepared this material references I have given, and simulation platforms. Further, embedded system, microbit.org, these all online simulation platform. I was making fun of this all. Realpython.com. These are all some of the fun I was doing across. That and all not suitable to deliver in the session at all. Maybe kids we can teach, that's all. Then these are wonderful research articles. You can read through that only. I have learned what is pruning technique, quantization technique, and teacher-student model. There are several techniques they have discussed. Very, very essentially 3 techniques. And for example, if at all you want to work, take up as a research quantization method, that pruning technique or optimization technique, we can take it up. It is purely mathematics. Deep learning we need to learn. Then after deep learning, fully optimization technique we can move on. That optimization technique, whatever we are finding the solution, that would be the classical solution for the embedded system. Then you can stick to optimization technique. Mostly in the optimization technique, you may need partial derivatives and differentiation, matrix operation, only very limited 3-4 mathematics, that also fundamental level. Don't go for like a mathematicians also. Kid level, how clearly the kid we need to teach. That level we need to understand. That's all. So that is more than sufficient for taking it up research in this domain. Embedded and deep learning means optimization. Without hard work, already shared Jyoti madam this link. See, already so many teachers are seeing, they have taken your copy also. Okay, I will share it again. And I will be sharing. This is the material. What you are asking, I don't know. Material, all of the link are given. That's all. Now hands-on. This hands-on notebook, I did it here using Colab. What is Colab? You no need to install. For example, Circuit Python, you need to have Circuit Python Adafruit bundle, and you need Mu editor installation. Whereas here, nothing like that required. It is part of Google product. It is cloud product. It will be useful for executing any of the Python program. TinyML also. For your specific topic given to me is TinyML. That is what deep learning for embedded system means. TinyML. Another word, a short word for the title which is given by the organizing team is called TinyML. That's all. They have given lengthy deep learning for embedded system. Generic word. That's all. TinyML is a technical terminology word. Now, how to start a Python code using Colab? Simple Python code. You want to start means this YouTube video I have made long back. How to start with the Colab, like that. Now also, without watching this video, you can work in front of me. You can work. How you can work is, this link is given already. If you wish, I can give once again the link. you can work simultaneously. Another 10-20 minutes, this code you can work. So people are interested in getting certification, not in the knowledge. Give the feedback link, they will fill and sleep, that's all. So now the link is shared. Now if you open, you can see you cannot execute. Click file and save your copy in Drive. After that, copy Atal embedded, it will come. You can change the name or leave, that's all. Then click. What I am doing, you also can do. So this play button, you need to press. Then it will start executing. Host only need to mute Amala madam because I am normal audience. Yeah, fine. Now it will take minimum 2 to 5 minutes for the execution. If at all you are executing, it will take minimum 2 to 5 minutes. So now I'm not executing because already executed, all the results are kept. Little bit is working, that's all. Import TensorFlow. I'm not using TensorFlow Lite. First, we need to build one deep learning model. I will tell the macroscopic level. This is the pure deep learning model, how the AI/ML department we are working for any model, any data analysis. That is pure deep learning. That deep learning model, see, I'm giving to TF Lite, TensorFlow Lite converter. Now that biggest deep learning model is compressed or miniaturized, maybe student model we can say, that is teacher model. So that student model is carried out or done in this section. That is what TensorFlow Lite. After TensorFlow Lite, what is the way we are doing? Further, see, TensorFlow Lite interpretation, completely deploying or testing. After converting TensorFlow Lite, we need to test whether really that model is working. So the one image is given, output detail 0, input detail of 0, test image. Test image is given, it is predicting, it is 7. What is 7? Then that 7th label, it may be donkey, it may be dog or cup. I need to verify that. That is what it is telling. Instead of 7 means we can give one print also. 7 means ball, 7 means cup. It is a CIFAR data set. It is ready-made data set only. It is taken. That data set is worked on it. That's all. The data set which is used is MNIST data set. What is MNIST is digit. It is popular data set. CIFAR and MNIST are two data set people will be developing any model initially before any new methodology people are inventing, they will apply on this only and they prove. It is 60,000 training images, 10,000 testing images. How it is possible to deploy it into embedded device? So this handwritten digit, that is MNIST. Then another one is CIFAR. This is another data set. This is kind of mixed, lot of images. Car, bird, horse, all. This is CIFAR data set. CIFAR 10, CIFAR 100. That is 10 classes. Then another one is higher classes. Then another one is fashion data set. Fashion MNIST. This is another data set. Fashion MNIST is, it is fashion, all fashion dresses. Shoe, shirt, kurti, baby, bag, fashion items. These are all the data sets people will be applying and proving their methodology or their proposed model or architecture. Now, in this work, the data set which is considered is handwritten digit MNIST data set. Nothing it is going to be applied. Somewhere we need to start the hands-on. Theoretically, how long we can speak? Just to reading the 10 point we can understand anytime. But hands-on only we need to really spend some time and learn, and we need to practice. Otherwise, there is no use of learning. The future of education, not theory teaching. Whenever teacher is versatile in hands-on, high-end skill only will be retained in the domain after 5 years. Low level of articulation, definition, these all of the people will be cut down because AI chatbot is ready to teach with all of the fundamentals. Only advanced. So from this moment, try to focus. It is a kind of humble request. If we want to fit into this academic system, we may need to accelerate our knowledge and the skill to the higher end level, not rudimentary level. Definition, application, telling challenges, reading the slide, and reading to 2-3 point will not fit enough to survive in the near future. So now coming back to from TensorFlow Keras. It is a complex deep learning. Keras, PyTorch, and TensorFlow. These three way only we can work. TensorFlow, some of the low-level APIs are not having. So for that low-level API, now TensorFlow is intercommunicating with the Keras. This is framework. If you say deep learning expert, they will be clearly writing on their resume. I am Keras expert, I am TensorFlow expert, I am PyTorch expert, or I am expert in all the three, or I am expert in any two. So every way, the way of doing coding or the syntax and understanding will be entirely different. That is how deep learning will have normal deep learning, not TinyML. Only three flavor: TensorFlow, Keras, and PyTorch. So now we are using TensorFlow, but TensorFlow is taking support of Keras. We no need to worry about that and all. So we use only TensorFlow. That's it. But TensorFlow internally, hidden way, it will take the support of Keras. For that, TensorFlow Keras, we may need to import. Why this TensorFlow Keras we are bringing is low-level API. Already I said TensorFlow will work on high-level API. Keras is having low-level API. So low-level means it is not low. Very micro-level, so microscopic level, it will work. TensorFlow superficially will work. So layers and models. What model we are working? What are all the types of layer we want? In order to specify these all, we need these two types of packages. So for that, we are using TensorFlow Keras. And model equal to model sequential. We need a sequential model. Whatever the animation I have shown or the playground I have shown, TensorFlow playground, all are having sequential. One after one, one after one, the input is flowing. That is what sequential model. Then layers.convolution 2D. So we are using image. 2D convolution is enough. When we are using video, 3D convolution we need. Now we are using image. It is two-dimensional data. So that convolution 2D. Then we are trying to have 32 types of kernels, filters, 32 different filters we are designing. We are dictating to the machine. I want 32 filters. Each filter is of the size 3x3. I said no kernel, it was passing one window. That window we are showing. What visually, ditto it will be mapping with coding. So 32, 3x3. Activation layer, ReLU. Already I said activation ReLU layer will be helpful for maintaining non-linearity. Any value 0 and less than 0, it will be converted to 0. Any value above 0 will be retained. For that operation, we need to, it is simple if then rule only, nothing more. If the value, any weight, any of the number flowing in the convolution neural network, any time the number or the value happens to become less than 0, I'm equating it to become 0. Any value, if it is happening to become above 0, highest value, I'm returning as such. That's all. Simple if then rules. But they are calling here it as ReLU, mathematical function. Input, that MNIST image, every image is of 28x28. It has only one channel because it is a black and white. You can see no RGB channel. So it is one channel, only one. Teacher training model is supervised. It is not a supervised or unsupervised, madam. It is a kind of transmitting the model. See, now this TensorFlow Lite next stage is student model. Right now I'm explaining teacher model. So this is not supervised and unsupervised. Both supervised and unsupervised possible to imitate teacher model and student model. Suppose imagine in your embedded system, you wanted to use an algorithm for clustering. Clustering means unsupervised, unlabeled data whenever you are working unsupervised, labeled data whenever you are working supervised. In such application, you need to use unsupervised. That also you need to apply again. teacher model, training student model, because bulky model will be available in the teacher and you need to make a miniature of that model. So now we are moving on to max pooling. After that, immediately layer we are keeping max pooling layer. All the necessary guidelines are given here and there. For example, here one by one it is there. Here somewhere it is input is here. I have given detailed notes, but I don't know, it is not available. Okay, leave it. What happened, I don't know. Yeah, fantastic. So next, coming back to max pooling layer, 2 cross 2 max pooling. That I said, no, the window will be 2 cross 2. Whatever is the maximum, it is reducing. Downscaling is happening. The original image is further downscaling. Then again, after downscaling, we are using convolution, because after downscaling, how the image is going to appear, what are all the features are going to be available, we don't know. That we need to take again. Then again activation layer. Then again max pooling layer. Then flatten layer. Already I said, the matrix information need to be converted into one-dimensional vector. That is flatten layer. Then dense layer. Completely dense layer, 64 neurons are fixed. 64 neuron, that player I was showing, no, that what to say, TensorFlow playground. So in the TensorFlow playground, this is what? So this is a neuron, 4 neuron, plus. Now 8 neurons. Like this, how many neurons should be there? That is called, where is it? That is called dense layer. The activation layer, activation function used in the dense layer is ReLU. That 64 neuron, what is the role is only ReLU, that's it. Then another dense layer we are using, that we are having only 10, because only 10 labels. So that activation function softmax. Now only that probability value will be generated. That probability value, it will have lower threshold to higher threshold within that one image. Some probability value, this is bottle, some probability value, this is mouse, some probability value, this is specs, it will be there. Based on that only, deep learning model will predict the given input image. Now, model.compile, optimizer equal to Adam. Now, within this all, we didn't tell straight, we didn't tell padding, we didn't tell how the weights are to be, how to prune, nothing we have mentioned. Automatically those all will be taken care by the machine. If the software want to take by itself, means we need to bring any of the optimizer. There are several optimizers available. One of the popular optimizer is Adam optimizer. We are keeping loss calculation. We are using cross entropy, sparse categorical cross entropy. That loss value it is showing 0.3345. Then accuracy 0.89. 0.99, 100%, near 100% accuracy we got it within 5th epoch. Within 5 epoch, very low loss with a high accuracy we have got. How we have got? Just randomly only we have designed convolution layer, activation layer, only 2 convolution layer, 2 max pool layer. Immediately we are flattening, immediately we are going for dense layer, then immediately we are giving output. This is the output layer. Surprisingly, it is working. Now, these are all called, up to this it is called model design. Nowhere input is given. You can notice. After designing the model only, see model.compile. The model is ready. After designing the model, we need to give the input. How we are giving input? See, tf.keras datasets minist load data. Now only we are loading the data. We are working on the data. What is this data? Already I have shown. Then it is giving this label. We need to be appropriate. We should give train image, train label, test image, test label, train X and Y variable, independent and dependent variable. This is called labeled. That's why this is supervised learning. What we are discussing is supervised. It is like that. See, who taught this is bottle in your childhood? Someone would have taught. This is supervised. have been taught this is a bottle. It is not an elephant. If I say this is elephant, you will think that I am mad. If I say this is bird, immediately you will step out of the session. She is mad. She don't know. She is telling this bottle as a bird. You will be laughing at me. So that who taught you? This is called supervised labeling. This is means this. This means this. Mapping is there. That is labeled data. That is called supervised learning. Now, train image. We need to reshape the image. That image will be in different dimension. That has to be reshaped. -1 when we are giving, machine will take care of automatic reshaping. -1, the power. You just imagine. If you want to reshape, you need to write the micro level code. This is to be rotated. This row is to be converted. A column is to be converted. If you just give -1, machine will take it. 28 cross 28 cross 1. So now, yeah, this is wrong. Yeah, right only. Okay, fine. I think one more notebook, detailed notes I have given. I will check it out. I will paste it in this itself later on. Now, 255 normalizing. This is called batch normalization. That image is 60,000 image. None of the machine can work on 60,000 images at a time. It has to take some bunch of images, then another bunch of images. Now 255 is scale color. That the highest scale color value is 255. So we may need to take bunch of images. That bunch of images we need to reshape. After reshaping, we need to normalize. Otherwise, pixel value will be heavy, 100, 250, 245. That heavy number, machine will be struggling to execute. So all of the bigger number, just imagine 245 into 40, if you multiply, what will happen? So that we are normalizing. This is called data normalization divided by 255. Then test image also, we are keeping it ready. The same method, how we are doing for training, the same method we need to do. Now, model we made, right? Model.compile. That model, we are fitting train images, train label, 5 epochs. 5 times only I am executing. Within 5 times, we have achieved 0.99. This no innovation. I have not done any research. It is all ready-made model. This I cannot submit it on the research paper because no novelty. Although the designing is perfect, it is reaching with the highest epochs to this accuracy. Nothing is my innovation. I have not innovated activation function. I have not innovated any new layer. I have not brought any new mathematics to every neuron. Nothing I did. All ready-made. Little bit tinkering work here and there and adjusted. And one model is ready. Then it is giving within 5 epochs 0.98 accuracy. Now model optimization for the embedded system using TensorFlow Lite. So now we are using TensorFlow Lite converter from Keras model. That model what we have designed, that model, that one word only model, that's all. That model is a word I'm using so that it is model. If you use anything, luckiest year 2025, then it will be luckiest year 2025. That's all. Model. So this, it will be converter. Then tf.light.optimize.default. What is the optimization technique? I am not doing any innovation. Default. What is TensorFlow Lite? By default, it is doing optimization, whether pruning or quantization or knowledge distillation. What it is doing, I don't know. I need to read that package. So that default is given. It is started optimizing. After converter.optimization, this converter.convert TF light model, my light model is ready. Now that light model, we are writing in a file, model.tflight write mode. This is write mode as file. SF means file. File.write tflight, TensorFlow Lite underscore model. This is what suitable model to deploy it into embedded device. So the normal deep learning model started. Now we are with the miniature model. This can be called as a student model also. The previous code is teacher model. Now we need to test it, whether that light is working or not. So TensorFlow Lite as TF Light. That is Ali's name. As means Lakshmi is called as, we say no, Lux. Most of my friends will call Lux. So it is like that. As TF Light, one Ali's name. Import NumPy as NP. Now TF Light dot interpreter. We need to do rest of the all. Then finally, see, we are feeding the input test images of 0. Then it is predicting the model output data. That's all. It is tested. Testing the miniature model is up to 7. That's it. The same notebook, I'm using it for tomorrow. The organizing team have given invitation for me to handle tomorrow AI in predictive model or predictive maintenance, one more session. I'm working on the hands-on model. I have not succeeded. Tomorrow I have 2 to 3 hours of free time. I need to work it. If it is working, I will handle hands-on, otherwise only theory. Let me try tomorrow. That's it. With that note, I also feeling little, what to say, tired of extending. If you have any questions, you come forward. Then finally, yeah. So session feedback is going on. Fine. So now I'm giving lastly the material once again. This is the one and only material you need to use. Hands-on also available, the Colab. So theory material, hands-on material, everything is available. You can preserve it. That's all. Yeah. Good night, all of you. Over to the organizing team.
Madam, having a small doubt, madam.
Yes, sir.
Madam, as you have told that there is a student model and teacher model, madam. The parameters which was learned by the teacher model will be sharing a few important parameters, or how, madam, that student?
Yeah, only important parameter. You yourself giving answer. Unimportant parameter, that low weight, that all called pruned. That
Okay.
whatever the low weight, that all link, that whenever the link is going, no sir, that line is going, no, that all lines will be broken. Only sparse model, here and there the computation will happen, here and there that line will flow, no density. That lightweight model only need to be fitted. That is what we are discussing, nothing more we are discussing.
Yes, madam, the parameters which will be shared will be done by the model itself, or we need to select the parameters which have to be shared?
No model, if we give it to default Python TensorFlow Lite, then it will select what it is default. We need to study that manual, easily we can understand.
Okay.
Otherwise we need to do research and we need to have control line by line. We need to write and we need to check all of the weight. Then what are all the weight becoming more important. We need to keep threshold and visual display. Visually we need to display then what is the output of the last layer, not going for the softmax layer. Before that itself, we need to display and we need to visualize how it is appearing, that cup, how it is appearing, ball, how it is appearing, where to stop. That all we need to take a common sense decision, and we can set the threshold also. These are all the several ways we can do, sir. If you are giving to default, we cannot even write research paper, because what is doing the TensorFlow, you also don't know, I also don't know, but our work is done. That's all. Research paper we cannot do, we cannot articulate. Now I also don't know that heavy model is given to TensorFlow model, it is becoming miniature. That miniature also we are not verifying. How many weights are there in the original, how many weights are there in the miniature model, that all we need to write a lengthy code, synthesize. We need to not the macroscopic high level API. This is called high level API. So that high level API will not be helpful. We need to go to low level APIs. Every level, every layer, what is happening, I need to have control on it. Then only it is possible to take decisions, sir.
Madam,
That's just to start with. But when we are doing deep learning, with a consistent way, then we can take that all of the report from the GitHub has a lot of code, sir. Level by level of visualization and intermittent result, where to code, where to configure, where to adjust. That will be of 2000 plus line. This 1.5 hour I cannot explain. I even don't know the 2000 line I cannot. So the 2000 line if you bring, it will be under your control.
Just I had tried out one experiment, madam, that I had used an RASNet 50, I think so, 50 layers to RASNet 18 layers, madam. While I had run for medical images, it's showing some error, madam. That is around, I'm getting accuracy of 90% like that. To improve that, what are the things I need to do, madam?
Changing the optimizer, Adam optimizer, any other optimizers, minimum 3 to 4 optimizers are popular. We can change the optimizer. That is one method. Or within the same ResNet, if you want to use only optimizer change.
Okay, madam.
Suppose if you want to change the ResNet model itself, you can go for higher end model. The dense layer, ResNet 100 is or 101 may be available.
Yes, madam.
That model we can go. Or else within that model itself, I want to bring means only changing the optimizer is the only way of working out.
Okay.
That optimizer will work different way with different hyperparameter tuning. Adam optimizer will work in different descent gradient descent algorithm. Other optimizer may use with a different mathematical operation. So we need to try optimizer with no work. We need to list of optimizers
Yes,
supported
yes,
by the Python for ResNet application. ChatGPT also you can ask. Then it will tell that optimizer name we need to change. Add them to different optimizer. That is for the same ResNet. Or else we need to crush that model or means keep it aside next to notebook. Another ResNet version we can use it. Then if it is working,
More
we
dense
can.
network we can use. Okay.
Yes.
Thank you. Any participants, do you have any doubts? Yes, madam. I
Madam.
would like to express my heartfelt thanks to you, madam, for giving a good session on applications of deep learning, teacher-student model, efficient deep learning architectures for embedded systems, TensorFlow practical application, neuromorphic computing. Just we came to know that name, madam. Previously, I don't know. Then TDML and Collabs also have done, madam. Thanks for sharing your knowledge, madam, which is very informative for the faculty who have attended this session, madam. Thank you, madam.
Madam,
Thank you very much
Lakshmi
for
madam,
your
good evening, madam.
Yes, madam.
This is Dr. N. Pushpalata, HOD of ECE, AITS Tirupati.
Yes, ma'am. Yeah,
This
thank
is
you for your mail, ma'am. Quite often you are communicating to me. Yeah, yes, ma'am.
this is third time, madam, but we have enjoyed a lot your explanation, madam. Keen explanation.
Yeah,
Thank you
you
so
very
much,
much, ma'am.
madam.
Because electronics faculty, that's why I am going with micro
But
level.
you are telling the way is very simple, madam. That's we enjoyed a lot.
Thank you very much. Yeah, I am happy that you are also witnessing and you are also active in listening even in the late evening. Thank you very much, ma'am.
Okay, madam. Thank you, madam. Okay.
Yeah, good night, all of you. We
Yes,
shall
ma'am.
meet again tomorrow the same time with a different topic, AI in predictive maintenance. That is a little bit challenging than even this.
Madam,
Here, at
I
least
hope
learning, I
so.
know.
I hope so. Tomorrow you'll be providing that total material, which was some contents are missing. I think so, right, madam?
Yeah. That tomorrow's material is missing. Yeah,
Okay.
the deep learning with detailed notes.
Yes,
Maybe
madam.
I would have done in different notebook. One for your session, one for my learning will be there. No, maybe in different. I will verify it and I will give it to you, sir.
Kindly share it,
Yeah.
madam. It will be helpful, madam.
Yeah, sure, sir.
Yeah, thank you.
Sure. Yeah, thank you. So because of practical, most of you are highly energetic, I guess, because this late time, most of the people are interacting means it is highly the worth rewarding. That is a real takeaway from this session. I'm so happy. Then I must work hard for giving you practical for tomorrow also. Let us see.
Thank you,
Madam,
madam.
next
Yes.
time we will meet in direct offline, madam, in our college.
Yeah, sure, ma'am. Deep learning, machine learning.
Permit me.
Yeah, I always machine learning, deep learning, theory, mathematics, code. These three I will be covering up and making it as a straight line. Definitely, I can do the justice for your expectation. We can meet again. Yeah, sure, ma'am.
Okay, thank you,
Thank
madam.
you.
Good night, madam.
Good night, madam. Thank you, everyone. Bye, all of you. Tomorrow we shall meet. I'm leaving from the session.
అది ఆయన పేరు ఫోర్తున్నారు సార్.
Reef sir,
మేడం
ఫీడ్బ్యాక్ లింక్ పెట్టారా చాట్ బాక్స్ లో?
పెట్టారు మేడం.
8th ది కనపరావట్లేదు నాకు. మొబైల్
Again, I'll
లేదు,
share,
ల్యాప్టాప్
madam. Again, I'll share.
మొబైల్ అనేది ల్యాప్టాప్ లేదు. పర్సనల్ గా పెడతారా?
Shh.